Good afternoon. Welcome to Navitas headquarters. My name is Stephen Oliver. I'm the Vice President of Corporate Marketing and Investor Relations. We have an incredibly packed day today. This is the first Investor Day at our new headquarters building. Those in person, you get to see that building later on today. For those on live stream, we will have some videos of tour segments posted by the end of day tomorrow Pacific time. I just have a few things to say first. The slides presented and a video recording of this event will be available on our website by Friday the 15th. Additional information related to our business is also posted on the Investor Relations section of our website. Our materials include non-GAAP financial measures. Reconciliation of these non-GAAP financial measures with the most directly comparable GAAP measures are included in the appendix to the materials to be posted on our website. In today's event, we will make forward-looking statements about future events or about the future financial performance of Navitas, including acquisitions. Forward-looking statements are subject to risks and uncertainties that could cause actual events or results to differ materially from expectations expressed in our forward-looking statements. Important factors that can affect Navitas business, including factors that could cause actual results to differ from our forward-looking statements, are described in our earnings releases. Please also refer to the risk factors sections in our most recent 10K and 10Qs. Our estimates or other forward-looking statements may change, and Navitas assumes no obligation to update forward-looking statements to reflect actual results, changed assumptions, or other events that may occur except as required by law. So here's a very brief highlight. Today we'll have several executive presentations on technical, sales, financial updates. We'll then have several voices of the customers. Thank you very much to the customers who are here today. Then we'll have the tour, that's Exploring Planet Navitas. And then by 6 o'clock tonight, for those in person, we'll travel to our evening event. As you can see, we have the ir.navitassemi.com website address, and we'll be loading the presentations very quickly. The Wi-Fi for those in the audience, if you haven't already got it, is the NavGuest password. So without any further ado, I would like to introduce our CEO and co-founder of Navitas, Mr. Gene Sheridan.
Thank you, Steve, and welcome to everybody. It's a really great day. It's a special day. Not only are we 10 years in the making, and in quite a decade it has been. It's been an incredible year that I'd love to share some highlights about. And we've got an updated vision and some major new announcements, especially as we look forward on a multi-year basis about electrifying this planet, Planet Navitas, as we call it, the future of an electrified planet. And we got a nice remodeled building, give it our own special Navitas touch throughout. A lot of fun things to share with you. We'll give you more details there. But before I dig in to the future, let's take a little look at 2023. It's been an extraordinary year at Navitas. And a time when semiconductors are pretty mixed. Actually, semiconductor numbers are actually down 9% this year. We couldn't be more proud about our financial performance. Revenues up over 100% compared to 22. Even more amazing, Deloitte recognized us as one of the fastest tech companies in North America, probably the fastest semiconductor company out there. 2,129% in just 3 years, the last completed 3 fiscal years. Pretty crazy. You might think, well, that's coming off a low base. Maybe it's a super low number. No, actually, there's a minimum revenue. It's the second year in a row we won this 3-year award. So pretty extraordinary stuff. Very excited, very proud about it. We're doing it while expanding our gross margins throughout the year. Very successful capital raise earlier this year. And we're very happy the stock price has followed nicely. Over 100% up year to date, more than double the stocks this year. But the financials only tell part of the story. A lot of this is coming through rapid expansion of the technology, our customer pipeline, and our customer relationships. Today we'll be announcing an updated pipeline of actually $1.25 billion. $760 million earlier in the year. Pretty extraordinary stuff. Where's it coming from? Not only is our core initial markets like mobile and consumer really nicely ramping, we actually see significant expansion into our new markets, electric vehicle, solar, industrial, appliance, data centers shipping this quarter for the very first time. Over 250 GaN chargers, more than that in development, 250 are shipping in production, 10 of the top 10 smartphone and laptop guys already in production with Navitas GaN fast chargers. Over 137 million shipped cumulatively across gallium nitride and silicon carbide. Pretty exciting stuff. We've been equally busy on the M&A front, as you know, 3 major investments in the last 18 months. Elevation for high-frequency silicon controllers, VDD for high-frequency digital isolators, and our biggest and most impactful GeneSiC, leading-edge silicon carbide technology that nobody knew about, but we know about it. Now we're using our system design centers, our global sales and FAE team, bringing this out to so many customers, driving a big part of that explosion in the pipeline that I mentioned, 1.25 billion. Quickly making investments in that area. Earlier this year, we signed a 500% increase in capacity with XFAB. That's ramping very nicely, fueling the growth of the business. And we announced a plan for $20 million of in-house silicon carbide epi investments, which actually are starting here next quarter. The building is under construction down below to prepare for the first of those reactors that would come in. And last but certainly not least, technology development. 4 major new platforms we're going to dig into today. Each of them have significant market implications, many of them related to the acquisitions we just made, and now we're rolling out new generations of technology. That includes Gen 4 GaNSense singles and half bridges, making a big impact in both motors for home appliances and mobile chargers and consumer adapters. GaNSense Control, taking those Elevation silicon controllers from that company we acquired, combining it with our high-frequency GaN to deliver high-density, high-frequency adapters. Generation 3 fast silicon carbide, the next generation of GeneSiC, already here, already rolling out, already getting designed into a ton of customers. And then maybe the most exciting for me today, GaNSafe. This is what we've been waiting for to open the doors to high-power GaN adoption. We all know we started with mobile chargers, consumer adapters. That's still relatively low adoption, single digit, maybe 10% adoption. We've got a lot of growth ahead there. But the idea of bringing GaN into these high-power markets is exciting, but also challenging. There's a reason many have tried and failed. We believe we have the winning solution. We're going to tell you all about it with GaNSafe. And then a real technology breakthrough. We're not even frankly sure of all the implications of it. Bidirectional GaN. Dan Kinzer and others are going to speak all about that program that has implications, I think, in probably every market that we're looking at addressing. Some very exciting achievements, announcements, recognitions in 2023. Let me touch on a few. First of all, it's our first year as the first and only pure-play next-generation power semiconductor company. Nobody else on the planet is focused as we are on a combination of GaN and silicon carbide without the distraction or dilution of silicon power devices. We do some silicon devices, but these are the auxiliary ones, the controllers, drivers, and isolators that complement and get more value out of the customer and out of the technology with gallium nitride and silicon carbide. Recognized by Forbes, this is pretty cool. I think we're top 50 or something as the best financial performance for small cap companies. That's a big name, a big recognition. Deloitte, similarly, recognizing us as one of the fastest growing tech companies, as I mentioned, but also non-financial. We're very proud. Last year, we announced the first carbon neutral semiconductor company in the world. This year, we've renewed it again. We plan to continue that and grow it, setting a standard for our whole industry. So, some new things we want to talk about. We've talked in the past about a $22 billion opportunity to displace silicon with GaN or silicon carbide in all of these various markets. That's an incredible opportunity for a company today that will do close to $80 million this year. And it's very diverse, driven by a lot of key factors in electrification and energy savings. For the first time today, we took a look at what Tesla announced back in February at their investor day. Tesla called it Master Plan Version 3. And Elon Musk outlined the steps and what it would take technologically and economically to electrify our planet. And his main point was this is possible. It's doable. It's economically compelling. It's less expensive than operating off of fossil fuels for the coming decades. And it can be done with technologies available today. Some of those key technologies are gallium nitride and silicon carbide. So we took his plan, how many EVs, how much energy storage, how many roadside chargers, how much of this, how many heat pumps, things we're going to talk about all throughout the day, translated that into the opportunity in coming decades for gallium nitride and silicon carbide. That figure is $1.3 trillion. Now, how does that relate to the $22 billion? $22 billion is what this industry is already shipping today, mostly with silicon, and we can convert that from silicon to GaN and silicon carbide. That's why we often talk about this as a displacement technology. If all we did was that, we have an opportunity to be an amazing leadership company, incredible financial success. But $22 billion is with the current state of electrification. Energy sources are only 20% electrified. That's solar and wind. Everything else is fossil fuels, coal-fired power plants, converted to electricity and then put on the grid. Look at the end applications. Also, about 20% electrified today. Gas cars, gas cooking, gas heating, all of those are still fossil fuel based. That drives the $22 billion. Where does the $1.3 trillion come from? We need to convert that other 80%. And when we do, the opportunity for gallium nitride and silicon carbide to not only participate, but accelerate and enable it is extraordinary. And it's $1.3 trillion over some period of time. That's up to the planet. That's up to us to all contribute and make it happen. Is that 10, 20, 30 years? But those numbers are extraordinary, taking that $22 billion potential to 30, 40, 50, even $60 billion a year. Pretty extraordinary. We're going to be publishing our own white paper on this investigation and study and analysis, and it really speaks to the real upside that we want to go pursue, not just financially, but the upside to electrify this planet. I'll break down the details. Electric vehicle is a big piece, not surprising. Everybody's talking about it. We're still early days in electrifying our fleet of transportation, not just cars, buses, trucks, every form of transportation is covered in the Tesla plan and covered by ours. But the size of these others are extraordinary. So energy storage, $123 billion. Solar inverters, $85 billion. Home appliances, wind pumps, heat pumps, wind power. The list goes on and on. Pretty extraordinary opportunity for us and for our entire industry. Now, with that said, the opportunity is immense. I think you came in here probably knowing that already. What do we do about it? How do we solve this challenge? And I look at this from an industry perspective, not from a Navitas perspective. And I really believe it comes down to these fundamental 5 key critical enablers or drivers. Of course, the technology is critical. Gallium nitride and silicon carbide are widely known as the key technologies to displace silicon and make this transition happen. But I would specifically point out it's the technology with the highest efficiency, the highest frequency, and the highest integration potential. These 3 things, efficiency not only drives energy savings, it allows you to shrink things down and miniaturize them and dematerialize them, allows you to have less energy burned up as heat, so you spend less money, time, and effort on thermal management. The frequency, of course, is the key to GaN and silicon carbide to switching fast, not because the chip gets better, but because more than half of the bill of materials of almost all power systems are in the magnetic and mechanical components. The EMI filters, the transformers, the inductors, the PCBs on the mechanical side, the housing, plastic or metal, all of that is usually half or more of the system. The faster we switch the power device, the more we shrink the size, weight, and cost of that other half of the BOM. So it's actually far more important to get the frequency up and reduce the cost in the rest of that than it is to take the cost of the GaN or silicon carbide chip down. And integration is something we're doing uniquely well with GaN ICs, integrating all those other circuitries around very cost effectively, mind you, not just integrating for the sake of integration, but when you integrate, you shrink the size and weight, but you also can do that and drive a lot of bill of materials cost. This is a key enabler that I think we're very well positioned on. We're clearly very focused on it, and you can expect to see exciting integration strategies coming out as it relates to silicon carbide into the future. But reliability is number 2. This is fundamental. This is a very conservative industry, and it's conservative for a reason. You have a very harsh electrical environment, high voltage, high temperature, high power. It's a very common place to have failure modes, and where the failures can bring things down, and when a power supply goes down, the whole system can go down. So it's for very good reason this is a conservative industry. You cannot sell these technologies on PowerPoint. You have to prove it in the lab, a lot of testing. And that's exactly what we've done. Designed in, lab tested, production tested, and field proven. Each of those are proprietary methods. Design in the protection circuits from the start. Intensive characterization. We have over, I believe it's 700 billion device hours of lab testing, over $10 billion device hours of field testing. really extraordinary. 137 million shipped, as I said, parts per billion, quality and reliability. That is not easy, and it's a multi-layered approach to deliver on it. System cost comes back to frequency, efficiency, integration. You've got to look at those other components. The chip is critical, gallium nitride and silicon carbide, to have that indirect impact on the rest of that system, and that's where the real leverage is on the bill of materials. Also, chip size is important. It's not just about wafer price, chip size. Our chips are 20 to 50% smaller across silicon carbide and gallium nitride compared to the majority of our competitors. Ecosystem, as I said, you better have influence and control over those other components I'm talking about, the controllers, drivers, and isolators. The magnetics, very important. So in the beginning, we partnered with others. Now we're developing our own. We continue to work with magnetics and system houses to really drive that ecosystem. It's very fundamental. And last but not least, education. This is an all-new way to design next-generation power systems. Power supply engineers in this industry for 30 years have been doing it the same way. The next 30, it's a different way. It's a different direction. It's not easy, but we've spent a lot of time educating ourselves, hiring the best engineers, going very deep on these systems. Each application, mobile chargers, EV onboard chargers, solar inverters, step by step, digging very deeply into those system requirements, understanding how to optimize it, now creating formal labs, which is now leading to joint labs with our customers where we can co-develop each of these applications to learn the system and drive that final phase of customer level adoption. Pretty exciting stuff, and this is basically the outline for what we're going to cover for the rest of today. Let me introduce some of the speakers that are going to be covering it. First and foremost, next up will be Dan Kinzer. He's my friend, business partner. We've worked together for 167 years, give or take. And we started in 1977 at IR. I joined in 85. We've been fast friends and business partners ever since. We created 3 to 5 different technologies, product families, and businesses at IR, all very successful. He went off to become the CTO of Fairchild. I went off to run my own company. We reunited 10 years ago. We always believed in gallium nitride. We started that program at International Rectifier in the year 2000, 23 years ago. We knew it was early. We also knew 10 years ago when we started the time was right to solve these remaining problems, drive those 5 things I outlined, and make this business a reality, which is what we're doing. So a super exciting and very proud moment for me to share this stage with Dan, but also to share it with brand new key members of our management team. Sid comes from GeneSiC. He is really the inventor and one of the key technical leaders, not only at GeneSiC and now at Navitas, but for the industry in the world of silicon carbide. He is as sharp as I've ever met, and he's a genuinely nice guy. And he fits perfectly in our culture. It's a great combination. And then you're going to hear from people you also probably have never heard from before, some of our great technical leaders at the system and applications level. Jason Zhang, Hao Sun are incredible at the power systems level. And it's very hard to find people that can be expert at power systems and understand semiconductor devices, semiconductor integration, semiconductor language, and how to bridge those two worlds, which is what Navitas is all about. Deep system expertise combined with deep semiconductor expertise. That is where the magic happens. And it happens with the leadership of these key people. Bring it all together from a customer perspective. David Carroll, who runs worldwide sales, would talk to you about how all of this is turning into a $1.25 billion pipeline, up 65% just from a few months ago. And then we'll wrap it up, of course, with how we're translating all this into financial excellence and scalability as we go forward with our CFO, Ron Shelton. And I just have a few other comments to add to our day. Steve described a little bit. We've got a bunch of surprise guest speakers in the audience today. We're going to wait, keep you in suspense, and announce them one by one when we wrap up here and give them a chance to tell you their view on why gallium nitride and silicon carbide are changing their industries and how Navitas is their partner to make it happen. Next, Planet Navitas. We're going to check this place out. As I said, we call it Planet Navitas, not just as our headquarters in the center of our global universe, but also as our vision in the future of an electrified planet. We're going to talk about how we design these GaN chips, design the silicon carbide, reliability and test, very critical and proprietary, as I described earlier, and then that deep applications and system engineering capability. A brand new demo area, and we've got a little twist to this. The demo area will speak to the past using old silicon, where things were in the last decade or so using silicon, the present, modern day, advanced gallium nitride and silicon carbide-based power electronics, how that's changing every industry we touch, which is basically every industry in electronics. But even more exciting, the future. We've created a studio. The studio is where we're creating our vision, our future of what this planet can look like when it's fully electrified and what that can mean to Navitas and our entire industry of gallium nitride and silicon carbide. Pretty cool stuff. You will be the first to see it publicly unveiled and to evolve over time. And we think you're going to love that little treat. And then finally, tonight, Steve talked about entertainment. It's not exactly the future of our planet. I'm personally hopeful it's the future of Los Angeles. They are forever in the shadow of the Lakers. Today, let's bring them out of that shadow and bring our Los Angeles Clippers, as we call it, Clipper Nation, at least to Laker status, if you guys could help them out a little bit. It should be a fun game. They're actually on a roll, 7-3 in the last 10 games. So even if you love Lakers, or God forbid the Warriors, give us a little love today for our Clippers, all right? All right, with that said, I want to thank you and bring up Dan Kinzer. Thank you, everyone.
All right, Gene, thank you for those inspiring words and also the words about our friendship over the years, which has been deep and gratifying and very productive, and I've always appreciated. I do lead both operations and technology, so you could say I sort of wear two hats, manufacturing and development, R&D. Most of the history, my history, has been in R&D, but I do have the privilege of also leading a very talented, excellent operations team here. And I want to tell you a little bit about both of those items. So first of all, I think it's been covered. I think you've heard a lot about this. But gallium nitride, silicon carbide, what are they? They are the best wide bandgap power semiconductor technologies out there in the world today. Who cares? What's great about wide bandgap? Well, the wide bandgap enables the semiconductor to withstand extremely high electric fields, especially when you're talking about 600 volt, 1200 volt and higher devices. That's really critical because you can make a lot smaller chips to handle the same amount of power with a wide bandgap semiconductor than you can with silicon. So it's about 10 times higher electric field you can withstand with both of these technologies, roughly speaking. And as a result, a lot of things shrink. The chip shrinks, the capacitance shrinks, it can operate at higher frequencies. GaN especially is basically an RF technology that we've repurposed for a power technology, so it can switch incredibly fast. Not gigahertz for power, but well up into megahertz and even tens of megahertz if you so choose. That's largely because it can switch 20 times faster or more with a very extremely low input capacitance. Everything with both of these technologies can shrink. It can be 3 times smaller, lighter, and charge things 3 times faster. And with the development of the technologies and the cost improvements we've been putting in and will continue to put in over time, and with the benefits of our system expertise, we can lower the system cost substantially as well. All of that while saving energy. And really, if you look at it, that may be our primary motivation, that we are really, as a company, trying to improve the energy efficiency of electrical applications and move from non-electrified to electrified applications, making it all cleaner, safer, and more efficient and less polluting. So speaking of that, our mission in the company is to accelerate sustainability. These are some metrics that we're following. On the upper left over here, we have our corporate goal for greenhouse gas Scope 2 and Scope 3 emissions. What does that mean? It's everything that we're doing here, the lights, the energy in this building, plus what we do in manufacturing. All of what our manufacturing partners put into our products are included in those Scope 2 and 3 emissions. Our goal is to, as we manufacture our products, continue to make those manufacturing processes better and reduce the amount of Scope 3 emissions in each of our products. Now that we're not just a GaN company, we're also GaN and silicon carbide for one complete year. We have a higher target to see a 10% down reduction in the amount of greenhouse gases emitted in the combined manufacturing of both GaN and SiC. I think that tells part of the story. Yes, in making our products, we do emit greenhouse gases. But if you look over to the right, there are two charts, one for GaN fast technology, one for GeneSiC technology. You see the arrows pointing upwards on the left. First of all, in the GaN, you see that there's a black arrow. That's silicon. That's how much greenhouse gas is emitted in making a silicon device equivalent to our GaN device. You can see the GaN device has a blue arrow pointing up. That's much smaller. It takes much less greenhouse gas emissions to make a GaN transistor because they're much smaller, and the process is actually simpler than a silicon superjunction device. That would be comparable. But you see the large blue arrows, which add up to the large green arrow, which is the customer needs far less materials in magnetics and heat sinks and filters and capacitors and everything to use our parts because they can operate at high frequency. So that benefit is quantified in terms of less greenhouse gas emissions and all of those materials. And then on top of that, with our increased efficiency, we need less electricity, which has to be sourced and usually is sourced from fossil fuels, hopefully not in the future, but now. So there's some emissions associated with that. So all of that adds up to a much larger impact positively to the planet of using our product than it takes to make the product. So we save 4 kilograms of CO2 for every GaN device. We see the same thing over here with GeneSiC, a small positive arrow up, but the negative arrow on green, we save 25 kilograms of CO2 for every silicon carbide part we ship. It's a great motivation to ship as much as possible, right? We're going to save the greenhouse gas emissions, the more we can ship, and that's what we want to do. We've also been recognized as a leader in sustainability by ESG Investing, and we have been certified as carbon neutral. The little bit of up arrows that you see in the manufacturing of our products, we've offset with carbon credits. So let's talk about the market opportunity. This is a pretty busy graphic that shows you a lot of applications for our products, and you can see that there are many. And therefore, you can understand why there's a $22 billion market that, as Gene described, is expected to grow substantially over time. In this corner, you have applications that are clearly going to be GaN. Those are the ones that are in the 650 volt range, and also GaN also has some capabilities in the 100 volt range. But many applications are in the 650 volt range because everything that you plug into the wall needs a 650 volt device to control the power coming out of the wall. So that's a lot of things. It includes adapters. You see many of those around, how we've improved the efficiency of those and shrunk the size by factors of 3 and 4 in some cases. Smartphone and tablet chargers, laptop adapters. You'll see a display of a very thin TV that can now be realized because of wide bandgap technology with extremely thin power supplies, less than 10 millimeters in thickness. Home appliances, a very big market for us. New products that we have in GaN for motor drives we'll talk about. And then we have a region of overlap. Again, this is 650 volts, but as you get up into the higher power levels, you can say both GaN and silicon carbide are relevant in that space, and in some cases may compete with each other. In other cases, they're just complementary. We'll use an ideally, one socket is ideally suited for the use of silicon carbide, another for the use of GaN in the same application. For example, in OBCs. We have other applications like residential solar, data centers, both the UPS and the power supply unit in data centers. And we are actively promoting both GaN and SiC technologies and working with our customers to find the optimum solution. Great thing about our company is we have both. Not many companies, in fact, I don't think any other company can say they have the leading technology, the best performing devices in both of those two technologies. Not only that, we don't have to be distracted by making silicon devices, so we're completely focused on it. Then you see in silicon carbide, and we have the chart going out to 6,500 volts. Actually, our friends from GeneSiC, their expertise doesn't stop there. They've made parts, I think, up to 15,000. They know how to do it. There's a very deep level of expertise that we have in-house on how to make high voltage devices, and silicon carbide is the technology that really is the right technology for 1200 to 6500 volt range devices. And you see some of the big applications, of course, the electric vehicle powertrain, especially the 800 volt battery bus technology for EVs, which is the most efficient one for higher power EVs. Industrial drives and robotics, also very key. Commercial solar, 1700 volts is a popular range, even maybe a little higher, up into the 2000s. Wind, 3300, going up towards 6500. Rail, also 6500. So we have the technologies to address this incredibly wide range of applications, and we're looking forward to doing so. This is our supply chain as it exists today. The supply chain is growing and evolving. We're bringing on new partners as we expand our portfolio. When you talk about chip manufacturing, it starts with, of course, the wafer, either the silicon wafer or the silicon carbide substrate. Right now, both of them are 6-inch substrates. We put epi on both, GaN epi and silicon carbide epi. We have suppliers for both of those services. The silicon carbide epi is a foray that we're making into manufacturing. It is, we're bringing in, and as Gene alluded to, in this very building, we're going to be putting epi reactors in. We have a world-class expert in silicon carbide epi that we've brought onto the team. He's going to enable this. He's done it multiple times in the past. This will help us with lowering the cost of our supply chain as we bring these technology in-house. And then we have our partners, TSMC and X-FAB. X-FAB is in Texas, TSMC in Hsinchu in Taiwan. And they're great partners. They put in all the capacity that we need and will continue to support us. We have agreements that will continue to take us into the higher volumes that we need for our growth. That being said, there are many other companies that are interested in doing business with us, and we are investigating other options as well. On the wafer front, on the assembly side, we have multiple partners through several countries in Asia, notably Taiwan, Philippines, Thailand, and China. And we are working with those and achieving the results that we want to see. From the beginning of our company, it's been a focus, as with most startups, but we particularly paid a lot of attention knowing that in gallium nitride, there really was sort of an open opportunity to integrate and to protect the inventions of our company. We developed over time a significant portfolio, over 250 patents. If you look at what we developed for the GaN technology, but what we've also acquired through GeneSiC with their advanced silicon carbide device and process IP, also Elevation with controller IP, and also VDD Tech with isolator IP, leading edge IP in all cases. We've really built up our portfolio of patents, and I would say it would be very hard to be a player in the field of GaN power integrated circuits without taking notice of this portfolio. So we do have proprietary designs and processes. A lot of the effort that we spent over the last several years has been building up a unique and proprietary process design kit. This means you have all the models, you have all the transistor designs, the component designs to build power ICs with. It's completely in-house. We overlaid it over the TSMC process, but no one else has access to it except our company. And as a result, we've been able to develop what I'll show you, some of the world's most advanced, probably the most advanced GaN power ICs that you'll see in the world. We've also had a tremendous rate of innovation. We are on generation 4 technology, both in GaN and SiC. We are planning future generations that are in development, and our goal is to release a new generation every 12 to 18 months. So speaking of generations, this is an evolution of the generation of products, starting with old, slow, and inefficient silicon, which we started by developing a device together with TSMC to replace silicon and to be, as I said, much smaller chips, much faster chips, but a little vulnerable on the input side. It's an enhancement mode gate. It should be driven at about 6 volts. If you overdrive it or don't do it carefully, you can overstress the device and run into reliability problems or failure. So what we recognized early on is that we should integrate. And that's how we developed all that IP around the integration, starting with the very first year of our company and developing over the last 8 or 9 years to improve and build upon our IP portfolio. The next step that we took and introduced to the market, we called it, it was our 3rd generation of product, GaNSense. We noticed that all of our customers are using inefficient sense resistors in the current path, in the main current path, to feed back to the controllers. And there was as much voltage being wasted and dropped and dissipated in the resistors as there was in the devices. That seemed very nonsensical to us. So we introduced this product called GaNSense. So we provide current sense feedback. We take that signal from just a tiny little piece of the current that's flowing in the device and losslessly, without power loss, send that signal to the integrated circuit portion. We do signal processing to improve the accuracy of it, and we send it back to the customer so they can have a good signal to trace the operation of the device. But in addition to that, we can provide protection features. So if it goes too high in current, or if all of a sudden a short circuit comes along, we can turn off the device before damage. And the controller can respond to protect the overall system. We added also the features of over temperature protection. In case it goes over the rated 150 degrees C, the system will react and protect itself. It's immune to ESD, human body model, up to 2,000 volts. And it has autonomous standby mode if it's not being used to reduce the quiescent current and the standby losses of the chip. We then introduced this. We went from a single device into a half-bridge device. And that's one of the big things we're talking about today. The half-bridge is a building block of most of the power electronic circuits in the world. And this one is widely already in use. The very first version of this has been sold in multi-millions of quantities, but we've now built out a whole portfolio that we're talking to you about today. And finally, GaNSense control. With elevation, we brought in the control techniques for a quasi-resonant flyback converter. We've got that controller now in the same package. We can sell you just the controller, but we can put it with a GaN chip and give you a fantastic solution for advanced high-density power adapters. So here's a bit more about the half-bridge. We're very excited about this product. We actually started working on the half-bridge from the very early days, knowing that it was critical. We've got a tremendous amount of IP around an integrated GaN half-bridge. Lots of different patents and different ways in how to do that. It includes that lossless current sensing feature. It's got all these attributes. The circuit is very small. You can see it uses much fewer components around it. That's all been, the functionality of that has all been brought into this very tiny 6 millimeter by 8 millimeter package, probably smaller than your little finger nail. And we can deliver hundreds of watts of power with this thing in motor controls and in power converters. So it has all those attributes that we discussed already about GaNSense technology. So this is a little bit about GaNSense control technology. With power adapters and with electronic applications in general, if they're less than 65 watts, you don't have to worry about the application causing disturbances on the grid. Even if you have many, many of these adapters, they don't worry too much. The regulatory environment is such that they say, I'm not going to worry about you distorting the waveforms on the grid with your your 50 watt or 25 watt adapter. But when you get over 65 watts, the regulatory environment says you have to have power factor correction. So we are also working on power factor correction solutions. And the adapters that are over 75 and 100 and 200 and 300 watts all have both PFC and DC to DC elements to them. And this is a great application for our single GaNSense devices and our half-bridge GaNSense devices, as well as our quasi-resonant and synchronous rectification controllers that we put into the less than 65 watt category. So, and we do that, as I mentioned before, the CoPack, which is a GaNSense control CoPack, controller plus GaN. So I wanted to spend a little time, and I really only focus on this in this one slide, but this deserves more than one slide, probably a whole seminar. But we are introducing a technology that will really change the game in a lot of applications. And I've listed a few of those applications. Some of those are PFC applications, some of those are converter applications, some of them are inverters, some of them are motor drives. This technology can have a major impact on many of those. What is it? If you look on the lower right, most systems take wall energy, convert it to a DC bus. There's a big caps associated with storing the energy, and then they take that energy and they convert it back to some sort of an AC waveform, some sort of a switching waveform. Could be low frequency like motor drives, could be high frequency like converters, but there's two stages in that process, and I just described that a couple of minutes ago. If you have this bidirectional switch, you only need one stage, and therefore your losses can be cut dramatically down, and the number of components that you use in your system can be cut dramatically down. Not only that, in semiconductors, we always want to make things smaller, right? We want to pack more things on a chip. If it's digital, you want to go from thousands to millions to billions of transistors on a chip. If it's power, you just want to get more amps and volts and watts out of a chip. So this is sort of a scale representation of if you were going to do this with superjunction silicon, make a switch of a given on resistance, it would be represented by those two red squares. And if you were going to do it with a standard unidirectional GaN device, it would be those two green squares. Obviously, you can see GaN chips to do the same job than silicon are much smaller. We talked about that earlier. But if you need a bidirectional switch, instead of putting two devices in series to block voltage positive or negative, like you normally have to do today, you just have one device. So you take that green amount of GaN and make it dark green, tiny little bidirectional GaN chip. So up to 9 times less material than is used in the silicon solution. Can be even higher, and we're seeing tremendous interest in this technology. I think it's going to be a game changer, and I think you'll hear a lot more about that as next year goes on and we roll this out to the market. And so Gene mentioned this. It's a tremendous, exciting thing for us for the near term. This is our entry into high-power GaN. Many customers are looking at this in the data center, solar, and EV application space. It has all the attributes that I mentioned on the GaNSense technology. It's GaNSafe, so it adds this extra attribute of high-speed short-circuit protection, which you need for high-power systems. What we call easy EMI. This device can be tailored to run and operate in a very quiet mode, not causing distortion, not causing noise, not interfering with other devices around it. And the packaging that we're putting this thing we call easy cooling. These are higher power packages with very low thermal resistance to the cooling system of the environment. They're very robust. They have transient capability up to 800 volts. You're going to hear a lot more about that today. So I'll leave it at that. And then just mention this critical part of our portfolio, this major part of our company now, GaNSafe technology. You're going to hear a lot about it. You see the key packages there that we're offering today. You see the range of our products up to 6.5 kV as we discussed. They are very robust, they're very fast, they operate much more cooler, is that a word, more cooler? Cooler, much cooler than the competition. And you can parallel these devices. They are rugged devices. I'm so excited about this technology, but without saying any more about it, I would like to bring the guy that really knows the most about it, Dr. Sundaresan, to the stage. Thank you very much.
Thank you, Dan, for the introduction. Also, thank you, Gene, for those very kind words. So my name is Sid Sundaresan. I'm the Senior Vice President for Silicon Carbide Technology and Operations at Navitas. I came to Navitas in 2022 through the GaNSafe acquisition, where I spent 15 years working on silicon carbide power devices. Now, as Gene said, yes, I mean, to the outside world, I mean, GaNSafe was like probably the best kept secret. To people inside the silicon carbide world, GaNSafe is no secret. I mean, I've been personally working in silicon carbide for the last 20 years. I mean, when I started in silicon carbide, we were working on like, less than 2-inch wafers, right? I mean, like even pieces of wafers. And it's been like really gratifying for like, people such as myself to see silicon carbide finally going mainstream and into all these applications, right? So we've kind of watched, we've had it, front row seats, right, to the journey of silicon carbide, and it's an extremely like gratifying kind of like thing for people such as me who have been in this for a long time. All that being said, I also want to like really thank the Navitas team for really accepting us, the GaNSafe team, right, as part of the Navitas family. So myself and almost like all of our 20 key people have made not only the transition to Navitas as a company, but also have moved themselves and their families all the way from the East Coast in Virginia. Most of us now call Torrance and like surrounding areas home. Okay, with that, let's get started. As Dan said, GaNSafe has the widest MOSFET portfolio in the world, silicon carbide MOSFET that is. We have parts ranging from 650 volts all the way to 6,500 volts. Total of 60 plus MOSFET products ranging from discrete parts, bare dies, and power modules. So what makes the Navitas or GaNSafe MOSFET special? There are MOSFETs, of course, as you know, offered by a bunch of different companies. So what's so special about the GaNSafe MOSFET? Well, it's our unique and patented device architecture that makes all the difference, and I will explain briefly what that is. The first silicon carbide MOSFETs that were introduced in the year 2011 were planar MOSFETs, similar to what was done in silicon. You see, the silicon carbide MOSFETs have more or less evolved along the same lines as silicon power MOSFETs, but there are a few key differences that I will point out. The planar MOSFETs introduced in 2011 by Wolfspeed, easier to manufacture. They can be, as a result, manufactured with high yield and low cost. Performance-wise, they are not so great. They have a higher on resistance per unit area. They have slow switching speeds, and they also have a high on resistance increase with temperature. Planar MOSFETs can be designed and fabricated to be reliable. They are mainly rugged due to the use of their planar gate architecture. In silicon, as you may know, the limitations of planar MOSFETs were overcome by moving to trench gate architectures. So unsurprisingly, the same has been attempted in silicon carbide as well. Now, there are many vendors, as we all know, who have already offered silicon carbide trench MOSFETs into the marketplace. And some of those vendors are listed here, and you can also see some of the cross-sections of those devices that have been commercialized already. What is common to all of these silicon carbide trench MOSFETs is that they need extremely complex manufacturing lines, often requiring very exotic process steps. Typically, a trench MOSFET has 30 to 50% more process steps than does a planar MOSFET. Consequently, they suffer from lower yields, or I should say they are prone to suffering from lower yields. They also have a very high cost to manufacture as compared to planar MOSFETs. Performance-wise, yes, you can make trench MOSFETs with lower on resistance per unit area as compared to a planar MOSFET. That's true. They can be designed with faster switching speeds. But the big problem with trench MOSFETs, which have been commercialized so far, is that they have a very high on resistance increase with temperature. So they may be designed to have a low on resistance at room temperature, but as the temperature increases close to the use case operating temperatures, the on resistance really increases a lot for trench MOSFETs. So what we have done at GeneSiC is really bring the best of both worlds. We've taken the best features of the planar MOSFETs, the best features of the trench MOSFETs, and combined into what we call a trench-assisted planar gate MOSFET. This MOSFET is easier to manufacture, similar to a planar MOSFET. Consequently, it can be manufactured with high yields and with low manufacturing costs. The performance is where the trench-assisted planar really comes to its own, because it has the lowest on resistance per unit area, fastest switching, and the lowest on resistance increase with temperature. So you see, the trench-assisted planar gate MOSFET is manufacturability-wise similar to a planar MOSFET, but performance-wise, it can rival or even exceed a trench MOSFET. I know this sounds very surprising, but it's actually true, as I will show in the next slide. Reliability is also somewhere a place where the trench-assisted planar MOSFET shines. Since it's mainly a planar MOSFET, the MOSFET channel is planar. The gate is pretty rugged. However, we also offer the highest 100% tested avalanche ratings on our data sheets. So how does the performance of the trench-assisted planar MOSFET compare with the competition, planar and trench included? So the graph on the left shows you the static performance comparison. The graph on the right shows you how the switching performance compares with competition. So the Gen 3 Fast version of the trench-assisted planar technology offers up to an 18% reduction in on resistance at 175C. It offers up to a 50% better switching figure of merit as compared to competition. If you combine the 2 points, what you get is lower losses and cooler operation. You can see the picture at the bottom right part of the screen. This is an in-circuit test conducted under identical load conditions on a GeneSiC MOSFET and a competitor MOSFET. You can clearly see that the GeneSiC MOSFET runs about 25 to 30 degrees cooler than competition. This leads to better system efficiency and a longer lifetime. Super important. OK, so here is our product roadmap for the next 2 years, 2024 and 2025. So in the early part of 2024, we plan to introduce our Gen 3 Fast silicon carbide MOSFETs, Gen 5 MPS diodes, followed by Gen 4 silicon carbide MOSFET chips, which are specifically designed and targeted for EV traction applications. We follow that with top-side cooled silicon carbide MOSFETs. Our very first silicon carbide module offering will be the so-called SiC pack. It will be offered in multiple topologies up to 150 kilowatts. Later on in 2025, we plan to unveil and release our proprietary SDC power modules. This is specifically targeted for EV traction applications. Top cool power modules will follow for OBC applications. And finally, last but not the least, we plan to also release ultra-high voltage silicon carbide MOSFET modules at 3.3 and 6.5 kV voltage ratings. Here is how we expect our technology roadmap to evolve. There are really three guiding principles that we use to evolve this technology, the trench-assisted planar technology. Point number one, continuously reduce the on-resistance times chip area, because by doing this, we can increase the amount of current that you can conduct with a given real estate of silicon carbide. Mind you, very expensive silicon carbide real estate, as we all know. It also reduces the cost per ampere. Point number two is improve the performance over the entire operating temperature range. Don't just focus on room temperature or just at high temperatures. Improve the performance throughout the temperature range. This is a very key point, and will distinguish our technology specifically over trench MOSFETs, which are primarily optimized for room temperature operation. Point number three is to continuously optimize the design as well as process to meet the ever-increasing demands from customers for increased reliability, increased quality, and increased robustness. So we started in 2018, where we released our baseline version of the trench-assisted planar technology. We called this the Gen 2. In 2021, we launched Gen 3 with a greater than 17% reduction in on-resistance. In 2023, we are about to unveil our Gen 3 fast silicon carbide MOSFETs, which in addition to achieving greater than a 12% on-resistance reduction, optimized driving, has better dynamic performance. That's what gives it its fast switching, and also will be fully automotive qualified. Beyond Gen 3 fast, will follow Gen 4, which has a further shrink to the unit cell. Again, it's the same unit cell that we're using throughout these generations, right? So it's by shrinking the unit, the unit cell shrink is achieved by layout and process innovations. And this will result in greater than a 10% reduction of the on-resistance. Finally, we are already doing extensive R&D on what we call our Gen 5 MOSFET. This is a radical, or this will be a radical, high power density technology. And this will have the capability to dramatically lower the conduction losses, especially at elevated temperatures at 150 to 200 degrees Celsius. And in fact, we are targeting greater than a 25% reduction on resistance at high temperatures with Gen 5. Okay, with that, I thank you very much for your attention. And I will then give the stage to Jason Zhang, who will tell you a lot of exciting things about our design centers.
My name is Jason Zhang. I'm the Vice President of Applications. Briefly about myself, in 2006, I was a part of the team at the International Rectifier, working on GaN products. International Rectifier was the first company to invest heavily to commercialize GaN technology. We predicted that the project will be completed within 3 to 4 years. In reality, the technology was harder to develop, and the market timing prediction was off by 10 years. So in the GaN industry, we're being regarded as the grandpas. So actually, quite a few of the early grandpas joined Navitas. So we're very happy after 17 years, the GaN adoption finally takes off. In our early days of Navitas, we have noticed only about half the committed project together with the customer ever got to production. There are many project failures at last minute, mostly due to the technical issue or due to the delay of the schedule. So you can see that the power supply design is quite complicated. It has about easily 100 components to thousands of components. When we use GaN to have a high density design, there are lots of new things, new components get put together into the system. So that creates lots of uncertainty, and there are lots of same learning happening from one customer to another customer. So we decided to help the customer and consolidate all the learning. So we firstly we created the mobile design center in Sheridan next to our key customer. So the process is basically we start with the business case with the customer, then we put together the finalize the target spec, all that, then put together the topology architecture with the right GaN product. And then we help them with the layout and put the whole thing together, complete the testing, make sure thermal, radio, EMI frequency, interference will be okay, and get a safety certificate. Then even during the production, early production, we still have to help them babysit all the way to resolve any yield issue or any process improvement. So we have to do this iteratively and to get it to work. So far, it's been very successful. And right now, we have 3 design centers, mobile, data center, and data center power, and the EV. So the data center, the design center, system design center is a critical part of Navitas' go-to-market strategy. So this is one example. We designed hundreds of adapters to the market. This is just one snapshot of the mobile laptop adapters. As you can see, there's so many customers. It should be very obvious to you. There are no 2 adapters look alike. They're all different. The customer always want their own form factor. They always want their own power level, right? So we try the standardization with them. They don't want that. They want their own customization. So to do that, many times lots of projects get delayed because the marketing of the customer want the round the corner or some other things, make it flatter or a cube looking or anything in that nature. The repack on the component many times requires a system redesign. We have all the toolkit. So it's a problem for the customer, but it's a really good problem for us to solve because we have all the toolkit. We can get it going pretty rapidly. So we'll give you a few latest platform examples we developed together with the customer. So this 140-watt design is a benchmark PD adapter. The PD basically is the reason adapter took off is because this standardization of this digital interface between the adapter and the load. Then once you have that standardization, you can get to high power. You can charge all kinds of devices with the same adapter. So traditionally, the power top to 60 watts, then later to 100 watts. With the PD 3.1, right now, the market, the highest power is 140 watt. When you get to 140 watt, you can use that to charge many mobile devices. So 140 watt is the state-of-the-art. It's made of GaN. It has GaN component in there. Our GaN component also in there. So we say, how can we make it better, right? Just say, this is the benchmark today. Can we make it better? So what we did is that we look at the system. They're using a 3-stage power conversion with our latest component. We can do 2-stage to save 1-stage power conversion and associated cost and efficiency penalty. And you made the system 25% smaller. And most importantly, it's $2.80 component cost reduction. That's like a 10 to 15% of system cost reduction. So there could easily be a refresh of the same product in the market due to the mostly cost and size benefit. Talking about the PD 3.1, the standardization, the power actually can go all the way to 240 watts. The next one to be introduced to the market will be the 180 watt PD adapter. It has more power. The size, the key performance target is that for mobile adapter to charge all kinds of mobile components, it had to be small. The adapter must be small enough to be in your suitcase or even carry with you, right? So if it's too big, then you stay home. Then you won't be able to serve its purpose. So this one, as small as the 140 watt design showed before, and you can deliver much more power. And the 180 watt, you can charge many components, like a fast laptop, gaming laptop, and even some of the monitors, lots of other things. So this will be a next wave in terms of the power adapter. Another example just shows you working with a leading OEM company. For gaming, there are lots of advanced on gaming laptop. The 300 watt is a popular power rating for the adapter. It's too big. The one shipped with together with OEM laptop, it's very bulky and heavy, almost as heavy as the laptop itself. So we have been asked a few years back, asked by the OEM to reduce that by half, reduce the size by half, such that you will make the whole system look very appealing. So we achieved that. We chose the right architecture at that time and the right component to reduce the size by half, and at the same time meet all the thermal safety, all the regulatory requirement. The problem with that, even though you get to the production, it's just a little bit too expensive, even expensive for the gamers. So it's not hugely successful at that time. Then recently, with the learning we had, we tried to look at this again. So we achieved the same density reduction, and the efficiency and everything is the same as before, but we get the same cost of those bulky adapters. So we expect this to be popular for the gaming company. The example I just gave you from the mobile design center mostly was from the mobile laptop, right? So there's another competing camp for the same PD space. That's from the mobile phone company. They're also using a bigger adapter to charge your phone faster, right? They can get the phone charged within minutes. But at the same time, the actual power also can be used for charging laptop and other mobile device. So there are lots of those overlapping requirements from two competing camps, and lots of need for our design center, right, to address their customer need with the evolving need. We're very happy with how all the toolkit to serve both needs. So moving forward, that once we have the reliability verified and supply chain robustness confirmed, we move to the adjacent market. In response to the government mandate, energy efficiency mandate, there are lots of opportunity in the motor space, motor drive space. Motor drive space is extremely wide and extremely large, basically from 40 watt all the way to, for our space, 40 watt to 4 kilowatt. That's the first motor drive market we try to attack. It covers like consumer high-speed hair dryer, right, and also the refrigerator, heaters, and also the factory automation stuff. So lots of opportunity for us to either help with the density or the efficiency. The benefit of GaN in the motor drive is this. So you can see there are two traditional power switches using silicon. They all state at the 6 kilohertz. All today's motor drive solution running at 6 kilohertz. The reason for that, you can see the bar, there's the switching loss, there's the conduction loss component, but total is the power loss. You can see the moment it go up in frequency, let's say by 3 times, the penalty is just too big. The whole thing just becomes too hot and too unmanageable. So they stay on 6 kilohertz. Again, on the other hand, has almost no penalty. It's a very flat frequency curve. We can triple the frequency for the same efficiency, and also even with that and the high frequency, we're still better in efficiency over the today's silicon solution. So with this capability in mind, essentially we can remove the heatsink inside the motor drive to make the size smaller. And also for some motor, when designed properly, a high frequency switching allows the better wave shaping for the motor signal and allow the motor to run mechanically more efficient. So that 2% is a big number for the motor efficiency improvement. So this is a few examples of the reference design. This design was done in Europe by our AE team, application team in Europe. The first one using our half-bridge product that just introduced, very, very tiny, very small, and single phase design, 150 watts, no heatsink. The size is about 2-inch wide in diameter. This platform has been successfully used in the consumer high-performance hair dryer product, shipping in volume. The second one, using Sheridan, right, become like a three-phase configuration. This can do 500 watts. Also, similar in size comparatively, no heatsink needed. So those, and also we have other platform get us all the way to 1.5 kilowatt, also with a similar size, with the latest component. So motor is a market we're engaging extremely actively, and we have a lot of engagement with the customer. They're perfectly okay with the reliability data we provided and also the performance we provided. Very impressive for them. The new product that I introduced, GaNSafe, we're going to demonstrate the capability of this part. Just to emphasize why this part is important, why the other part is not enough for this high power. High power customers are very conservative, right? They're okay with the GaN because of the proven reliability, but they're not okay with the brand new packages. We must use their proven package, so like a rugged proven package. They need that for like a thermal management and also for the like temp cycling. There are lots of special requirements. They don't want us to touch it. To put our platform into this robust package, we have to redesign our chipset, driver, and again, all that, and we did that very successfully. The input, the configuration, pin out, extremely simple. Compatible with today's driver, no system, almost like dropping into the silicon socket. You can get it to switch. You can run very fast. And the reason the discrete GaN so many times for so long hasn't been successful in high power, mostly due to few problems, mostly related to the so-called ruggedness issue. One example is like ESD. 2 kV ESD requirement is standard. Without any protection, the GaN discrete can only handle about 500 volts. You rely very, very careful handling in order to prevent the ESD damage in manufacturing. So obviously, we can easily meet that 2 kV requirement. The short circuit overcurrent protection for motor drive, any high power, is a frequent occurrence. It happens all the time. And the device has that inherent capability. The silicon carbide all have some inherent short circuit overcurrent capability, but GaN does not have any inherent capability, right? So they rely on the system to provide the protection, but that's not foolproof. If there's any delay, any noise, it just won't provide adequate protection. So we're bringing the inherent protection back into the chip, and we'll do the demonstration. You will see you can have a repetitive overcurrent short circuit event. The device is safe. It's just a peace of mind for the customer. So we have a family of this product. Also, we're engaging with the data center and the EV customers. So this is the last slide. Essentially, with a proven success in mobile and established reliability and field data, we are very comfortably moving to a higher power into the data center, EV, industrial applications. Next, our design center expert, Sun Hao, will talk about the high power project he's working on.
Okay. Hello, everyone. Yeah, my name is Hao Sun, and based in Shanghai, responsible for Navitas EV Design Center now. And originally, I worked in Delta Power Electronics for about 16 years, and handled the whole Delta automotive power in China region. And my original work, I had about 6 years about data center power supply design, and another 10 years for the automotive power design. So very glad to be here to introduce our data center design team and also our EV design center. So first is about our data center design team here. So we all know that the OpenAI or some other AIs grows very fast recently. And if we want to get a very smart AI, we must train them with a lot of data and a lot of energy. So then all this data will be stored in the data center and need the power supply system of the data center to drive the AI ICs. So that means our data center design team mainly focuses on this kind of power supply system of the data center, named the CRPS. So with AI's growth becomes smarter, means that the power of the CRPS will become higher in the future. That means this kind of system must have the capability to provide the high power, high efficiency energy to the data center and the AI systems. So if we see the trend of this CRPS, so we can see that the GaN device and the SiC device will use its unique benefit in the high frequency, low power loss to support all these trends promoted here. So next slide, we can take some detailed numbers to say how this trend happened. So originally, the original design mainly with the silicon device, but with the old design, we can see that the efficiency only can get about the platinum requirement, mainly focused on the 94% or around that, and the power density lower than 100 watt per cubic inch. And also the peak power not so high, the hold time only stand about 10 milliseconds here. But now, if we use the GaN or SiC, this kind of wide gap device design in the CRPS systems, with the efficiency, we can increase it to some titanium requirement, high to about 96% here. And the power density can improve almost double. And the peak power can improve to about double here too. And also hold time, we also can improve it about 40% higher. But in the future, if we can use some better device like our GaNSafe and GaNSiC inside, we also can get even higher efficiency for the whole systems. And also the power density higher, because power density higher means that you can keep the same size but provide more power to the system. So, and also the peak power can be double, and also the hold time can be about 20 milliseconds. This is very important to the CRPS, means that if the power grid drop, you also have time to store your data in the system. And what's our data center design team do now? This is a demo I want to introduce to you all. So this is a CRPS named the 3.2 kilowatt system. This system is a 12-volt power supply to supply the whole data center. And it can transfer the power from the power grid to the low voltage to the data center and also the AI ICs here. So for this design, so we use our newest parts, the GaNSafe and the GaNSafe here for this system. And here I must highlight that so the system our design center made here is not a simple board. It's not a very simple board as the traditional semiconductor company doing originally. So this system is something like a real product, including all the mechanical, all the electrical, all the software, and all the reliability design concept inside. We name it as almost 18% to 19% real product. So with this design, we can see that for the GaNSiC part, we use it in the AC/DC stage, and the GaNSafe part, we use it in the DTC, the LC stage. And even with this design, even we compare it to, because we use the GaNSafe inside. GaNSafe had a much reliable driver inside compared to some discrete GaN design, and it can handle very high power. So even when compare it to the existing discrete GaN design we can find in the market, the power density also can be double higher than the original design, even with the discrete GaN here. And also the hold time, we can get another 40% higher here. And for the power, because we can support high power with our packaging and with our GaNSafe device inside. So we can get a true 3.2 kilowatt power for our design. And the next demo for the system is the 4.5 kilowatt AI server. So we designed in our data center design team here. So the same part uses the AC/DC, GaNSafe uses the LC, but you can see we can keep the same size with the 3.2 kilowatt here, but increase the power almost half to about 4.5 kilowatt. Means that the power density can be improved about 50% higher from 100 to 138 watt per cubic inch here. And even the efficiency can be high to about 97%. If we compare to the original design with even with the discrete GaN or with the silicon or with some others design, all the power density, efficiency, and home time, we can get a big improvement and all ahead of them. And second is about our EV design center. Yeah, we all know that so EV is driven by the electricity. So in the EV system there is the OBC, there is the traction inverter to drive the car, OBC charge the car, DTC transfer the energy from the high voltage battery to the low voltage battery system to supply all the low voltage system in the vehicle. So our EV design center mainly focuses on all these high voltage power units in the EV here. And we all know that everyone wants the EV to run faster, to charge faster, but run longer. So SiC can be used in the traction inverter to get more power efficiency for the driving system. And GaN and SiC can be used in the OBC and DCC to make that smaller and lighter, to enlarge the range extend the range of the EV, and also can get more power in the same size compared to the original design. Yeah, so here the GaN and the SiC can play a very key role in this kind of system design, because GaN and SiC, they have the unique benefit in the, as I said, in the high switching frequency, low power loss, and a very reliable system, and a very low system cost here. And if we take a 6.6 kilowatt OBC as an example, we can see the trend of the automotive power, what happened during the past years. So the old design in that side is the very old design with some silicon-based design, OBC, 6.6 kilowatt. In that time, the power density is only about 1 kilowatt per liter. So very, very, very big one. And now the main product you can find, the mainstream product you can find in the market is focused on the 2.5 kilowatt per liter or 4 kilowatt per liter here. But in the future, it will become about 5 kilowatt per liter or even higher. Means that 5 kilowatt per liter means the product, the size is only about a hand size here. So with this trend, we can find that means that if we can keep the same size as originally, now we can go to almost the 5 times charging power than originally here, charging faster. This is a very key feature for these ones, and also reduce the weight to extend the range of the EV. So what our EV team build now? So this is also high performance 6.6 kilowatt OBC combo we built recently. So for this one, we use our GaNSafe and GaNSafe inside, GaNSafe for the AC/DC. The frequency around about 100 kilohertz, not so high. But GaNSafe we used in this system is that we run the frequency high to about 1.2 megahertz. So with this kind of frequency, we can reduce the meg part very, very small, and to increase the whole power density to about 3.9 kilowatt per liter here, and also reduce the weight to lower than 5 kilograms. And another amazing point is that for the efficiency, you can say, even with such a high frequency design, we also can keep even a little higher efficiency than the original and the traditional design. So this is the first time in the industrial level we can get that. Yeah. And also another one is about our 22 kilowatt OBC the system. So this one is only with the GaNSafe inside, because this is a three-phase system. So three-phase system means it's 800 watt bus, 800 watt here. So for these ones, we use the GaNSafe inside, and with the GaNSafe very high performance, we can build this demo to a very low size, only lower than 7.1 liters. So the footprint of this one is similar to an A4 size paper. So if you can imagine that, it's something like that. And the power density, we improve it to the 3.5 kilowatt per liter. So this is almost double compared to the existing product you can find in the market. And also the weight, we can keep it lower than 10 kilograms. And the efficiency also can be high to about 96%. All these parameters are ahead of the existing product. You can find that here. Okay. Thanks for your attention. Yeah, next will be Deb.
Great, thank you very much, Hal, and it's really, really exciting for me to be here to talk about the pipeline. So you've heard the vision from Gene, the technology from Dan, and some of the device differentiation from Sid and from Jason, the design center differentiation and value that we can bring to our customers from Jason and as well as from Hao. And now let's talk about customers. And obviously that's where it all comes together, and what are we doing to build our business, to build a sustainable, high growth business going forward. So in May, it was the first time we announced publicly a pipeline. So in May, we talked about $760 million. Now, as a reminder, this is qualified customer committed engagements. This is customers where we've identified a strong technical fit, strong value proposition, and these are programs that we expect will go into production in the next several years. We're taking conservative lifetime estimates for these different market segments, meaning 1 to 2 years in the mobile and consumer space, and 3 to 5 years in the other target focus market segments that we're engaging in. And so again, in May, that was a $760 million pipeline, which actually I think is quite interesting, quite compelling for a company our size. And as we're integrating these different acquisitions that you've heard about today, since in those 7 months, we've increased the pipeline to $1.25 billion. So just in 7 months, pretty extraordinary growth in our pipeline. And I think that's really a reflection of this amazing market opportunity that's in front of us that Gene talked about. It's also a reflection of the differentiation of our products, the differentiation in the way we go to market, the way we engage with customers, leveraging our design centers. Okay, so I'm going to go in each one of these segments by individual segments and go into more detail and dive into what we're doing with different customers, how we're growing this pipeline. So starting with EV. So we've grown that pipeline 34%. It's north of $400 million today, spread over 130 different projects. We're targeting diverse applications within the EV segment, starting with onboard chargers. You heard a lot about that just now from Hao, but other applications as well. Roadside chargers is a really important market. Fuel cell systems, e-bikes, e-scooters. So not just your traditional electric vehicles, but anything that's electrified and provides transportation. Today we have significant silicon carbide revenue in tier 1 EV players. We expect to ramp our GaN revenue in 2025, and we'll do that with a variety of different applications, including hybrid designs which leverage the best of both worlds for SiC as well as GaN. We're driving and growing this pipeline worldwide across diverse regions, tier 1 OEMs here in the US, as well as in Korea, Europe, Southeast Asia, as well as in China. We're leveraging all of those advantages you just heard about from Hao in this market, ultimately to drive a better consumer value, lower cost, longer range, and faster charging across a wide variety of voltage ranges. And we're accelerating time to market with the design center and the really compelling system designs that you just saw Hao talking about. And really a great example of that is our partnership with the Geely Group. Geely is one of the largest automotive players in the world. They have multiple worldwide automotive brands, including Volvo, Zeekr, Polestar, Smart, many other leading car companies. So we partnered very closely with them. We established a joint development lab on site at VREMT, which is a Geely subsidiary that's responsible for the electronic subsystems for Geely. And from concept to start of production, we were shipping an onboard charger DC-DC integrated solution within actually less than 12 months. So that's actually astounding. And if you think about that and you put that into the context of a traditional electric vehicle or automotive design cycle. And we did that because of this close, tight collaboration with our customer. And so we're repeating that model over and over again across a variety of tier 1 OEMs and their ODM partners around the world. We have a similar strategy, and we can leverage a lot of those same resources and design capabilities as we look at roadside charging. Roadside charging is obviously a huge market, growing market, huge investment. Today, we have our silicon carbide technology in more than 50% of roadside chargers in the United States through our partnership with SK Signet. We're expanding and growing that footprint into other partners in roadside charging. And we're working closely to develop solutions that will take the current 350 kilowatt state-of-the-art roadside charger from Tesla up to a megawatt or more. And we're doing that in the same fashion that we're doing it for other EV applications. So it's a huge opportunity. Obviously, the biggest opportunity, if you saw the data that Gene presented earlier, we have huge growth there, $400 million pipeline, up 34% just since our first announcement in May. Okay, now moving on, solar and energy storage. Again, really important market. In the big vision that Gene talked about, this is key to the electrification of our world. We've grown that pipeline. Again, 66% growth, north of $250 million in revenue, spread across 70 different projects. This goes into a variety of applications, traditional string inverters, where we have silicon carbide revenue today, next generation microinverters, where we're leveraging our GaN technology, which we will be ramping in solar in 2024. Again, this cuts across multiple diverse regions, US, Europe, and China. Again, many of those same similar advantages come into play for solar. There's some unique attributes to the solar market, of course. Low cost, high efficiency is very important. Small size and weight, and some of that is just practicality of how do you install the systems, how many people do you need to install a system in a residence or commercial application. And we're leveraging our bidirectional GaN in this energy storage and solar applications as well that Gene and Dan touched on earlier. More specifically, we have multi-generational GaN designs currently underway with the microinverter market leader. We have GaN programs kicked off in the North America string inverter market leader. So this is a transition moving from traditional silicon to GaN, as we've talked about before. And we're in the majority of the top 10 customers today in mass production for string inverters. So this cuts across, again, multi-regions, all of the major customers in terms of top 10 players worldwide in solar. Okay, moving to appliance and industrial. So this may be surprising to some of you, the opportunity that's in front of us and that we're actually, frankly, creating with our advanced GaN and silicon carbide solutions. This is a really exciting growth opportunity for our company. The pipeline's up 250% just since May, up to $360 million and more across 200 different projects. And this is an area that we've developed significant momentum in tier 1 customers across home appliance as well as industrial applications. And again, a diverse set of customers here in the US, in Europe, as well as Southeast Asia and China. Specifically, we're engaged with 7 of the top 10 home appliance manufacturers. We're shipping in the hair care leader flagship product in high volume mass production. We are engaged in multiple generational follow-on designs and engagement and applications in the floor care and hair care market leader worldwide. That represents $20 to $40 million in future revenue, as an example. Additional examples, we're engaged in refrigerator design with the top 3 designer and manufacturer in Europe. Again, that represents $10 to $15 million in future revenue. A dishwasher design here in the US, $10 to $15 million opportunity by itself. There's obviously many others across those 200 different projects. And every application that you can think of is moving toward electrification in home appliance. They want the higher efficiency, the smaller size, the lower cost, and all of that plays to our advantages. And we're taking, again, similar, you saw some reference designs from Jason. We're proving to these home appliance players that tend to move relatively slow, that they can leverage this GaN and get this value for themselves, for their customers, and they're moving forward with many designs, which is driving this pipeline. Again, the market moves a little slow relative to a mobile charger, for example, but that would be, we'll start to see revenue late next year, ramping in 25 and beyond in home appliance, beyond the existing home appliance volumes that we're shipping today. Now moving on to industrial applications, this is also a huge market. It's actually kind of mind-boggling when you really look at the numbers. And I think, again, Gene touched on some of those numbers. Just heat pumps alone pop out as a massive driver for future electrification, moving away from fossil fuels. We have really strong, broad customer engagements today across all of these applications: pumps, air conditioning, heat pumps, industrial motor drives. Specifically, we have a heat pump design in the top 3 player in that market. That could be $25 to $50 million, just that design alone. And then we have 2 out of the top 3 industrial pump players that are currently designing with our solutions. That, again, it will take a little time to get to revenue, but we expect as we get to late 25, early 26, that represents $15 to $30 million going forward. So it's in a very exciting market in terms of migration from traditional silicon and driving into both GaN and silicon carbide. Now moving to data center. So data center is a very exciting space. We see AI is inevitably driving and pulling the power density and efficiency ever higher, and that's a perfect fit for Navitas. We've increased our pipeline to greater than 80 million, growing at about 17% just since May, and we're focusing on that bleeding edge of the data center market. We have, as you saw earlier, we have reference designs that we can leverage that can accelerate time to market. We have engagements with the top 3 power system players. We have multiple engagements across multiple power levels, and we're going to continue to drive that tier, that bleeding edge tier of power density and efficiency. And the market is moving. It's perfect for us because that's where the market's moving, and that's where we can deliver the best value with our silicon carbide as well as GaN, and in some cases hybrid silicon carbide and GaN solutions. These power system engagements that we have then lead into these end customer targets, the major data center providers that we all know well here in the US as well as in China and around the world. So this is, again, a huge market. We're just at the very beginning of it. AI is only going to accelerate this push to higher power density and improved efficiency. And then finally, and last but not least, mobile and consumer. So mobile and consumer, it's where we started. It's very exciting. This is the way I looked at this. This is a bit of a proxy for what we are going to see in the other markets that I just mentioned. 5 years ago, we predicted this reality. GaN is going to go mainstream. GaN is mainstream today in mobile and consumer. It's very exciting. It's very gratifying after many years of working together closely with our customers to see this transition, and it's happening before our eyes, and we're seeing it every day with more and more demand, upside demand from our customers, and we're keeping up with that demand. We have lots of capacity, as Dan mentioned earlier, but it's a great trend, and it's only going to continue. As Gene said earlier, we're just getting started. I mean, the market is so big, and even what we're seeing today is just the very beginning. But it's exactly what we said would happen. It's difficult to predict exactly when it will happen, but we knew it would happen. We knew we would enable it, and that's what's happening today. So we've grown the pipeline now to 150 million plus, 50% growth just in the last 7 months across mobile as well as non-mobile consumer applications. We're now shipping in 10 of the top 10 mobile players, including the 5 major mobile phone players as well as the 5 largest notebook OEMs. So That's quite a statement. It's a statement about GaN adoption, and it's a statement about the value of Navitas. And we're seeing this displacement shift occurring in a big way in many different places, none more clear than in China. Xiaomi and Oppo, they expect 30% at least of their mobile phone chargers will be GaN-based in 2024. So that's a massive shift. It's proof of this as a mainstream technology now, and that's only going to expand going forward. What's fueling all of that growth and that transition? Here's some examples of recent Xiaomi and Oppo phone launches. These are not niche phones or super high expensive phones. These are mainstream phones, super high performance, great battery life, huge screens, state-of-the-art phones from kind of 67 watt power levels for their charging requirements up to 240 watt power requirements. A mobile phone charger that's 240 watts, maybe 4 times what you might carry around for your notebook. So it's pretty amazing, pretty compelling. Charge your battery in less than 10 minutes from 0 to 100. It's really exciting and compelling stuff, and that trend is only going to be continuing to grow across the world, and over time, that percentage of 30% is only going to continue to increase. Jason talked earlier about some new products and new developments that we have in even higher power applications. We're leveraging that mobile design center to drive new 100 watt and above designs. And again, that market is only getting bigger as well. That represents more than 10 million in revenue just in these 12 programs that we have today. So mobile is really exciting. And then layering on top of that now the non-mobile consumer market. We've been engaging there for a long time. We've had some good successes in desktop PCs, gaming PCs, but now we're seeing real traction in the gaming market itself, the game console market. We're actively engaged with the top 2 game console players worldwide for future generation development. So this is really exciting. They can leverage the smaller size, higher efficiency, and more power density to make more compelling products for their customers. It's actually and obviously a massive, massive opportunity. We also see applications for other non-mobile consumer applications like home networking, audio systems, as well as TVs. TVs get larger, but they get thinner and flatter, and they require more and more power. That's a perfect fit for our integrated GaN ICs. So we have multiple Tier 1 TV OEM design-in engagements underway today, and we expect that we'll be announcing Tier 1 TV shipping starting in the first part of next year. So I've listed some names here. You can see many of the key players in the top 10 Tier 1 mobile players. We also have really strong partnerships in the aftermarket. Many of these customers are really the pioneers, the ones that really led the way to show the world what you could really do with a GaN-fast IC. And I know that many people, all of us in this room, have experienced that, what that really means. It's exciting to be able to see how you can pack so much power, multiple ports in such a small space. A lot of that innovation doesn't come from those top 10 players, but it really comes from our aftermarket partners and companies like Belkin and Anker. Those are great examples of customers that we've partnered closely with over the years to really drive the envelope in these mobile charger applications. So that's a quick overview. Hopefully gives you some more color on our pipeline, our progress. I think the extraordinary growth that we have achieved just in the last 7 months in our pipeline really sets the stage really well for us to continue to drive our revenue growth, to diversify into all these various markets while we continue to grow in our traditional core mobile and consumer markets. Okay, with that, I'm going to hand it over to Ron to talk financials.
I think that was for me. Applause, but thanks, Dave. Hey, everybody. I'm super glad. I'm looking out, and first of all, I see a lot of familiar faces, people I've known for many, many years.
And it's great to see. I mean, this is telling me what it tells me today, and I roll back a year or so, that when people think about the power semiconductor market and where it's transitioning and where it's going, it's not some of the old legacy companies, right? I think it's about us. I mean, we are, from a technology standpoint, from a product standpoint, from a focus standpoint, I think we check all those boxes to really win in this market. And when someone, and I've known a lot of you, and some of you may have asked me, I joined here middle of 22, and they asked, well, why Navitas? And we've all had a chance to sit here and listen to Gene and Dan and Jason and Hao and Dave, and I think it's pretty obvious why. I mean, we are positioned to drive some significant growth and really drive this market forward. So what I think I'll do is, not what I think, I'm going to go over 23. We've talked a little about 23, but I'm going to look back at 23 and then go forward. We'll roll it forward, talk about how we see gross margins rolling out, a long-term model, how we're going to invest, where we're going to allocate capital, and so on. So let me just jump in. So if we go back to the beginning of the year of 23, and you think about what were we saying then, almost 12 months ago? And we went out and said, look, we think revenue is going to more than double this year. And in a tough macro, tough environment for semiconductors, we're more than doubling this year. We talked about our gross margins expanding throughout the year, and they've done. Each quarter they're up incrementally, and we've, in our Q4 guidance, we've indicated they'll continue to expand next year. OpEx, we've been investing, and clearly investing for growth, and we will continue to do so. But we've consistently talked about, look, you will start to see leverage in our business on the OpEx, and that's what you're seeing now. So OpEx as a percent of revenue is declining significantly. Working capital, we want to be really, really efficient. I mean, people trust us with their capital. They've invested a lot of money in us, and we want to be super efficient with how we manage capital and manage our balance sheet. Just a couple things to look at there. Our inventory turns are up over 3 times. And our cash conversion cycle, which we really focus on, is down by almost half in the last year. So we're making tremendous progress on the balance sheet and working capital. And look, at the end of the day, what it comes down to, are we delivering returns to our shareholders that are in excess of our competitors, our peers, the indexes, and so on? And I think we're doing that this year. Wrong button. So let me just talk about revenue and break it down. I think you see the annual revenue. Gene pointed out, look, we're winning awards from Deloitte and Forbes about the fastest growing companies and being on those lists. And then if you look back at this year, though, and you look at the growth and how it's rolled out, a few things are happening I'd like to point out. So we did acquire GaNSafe in Q3. So Q4 of last year is the first full quarter with GaNSafe. And so the doubling continues, Q4 this year on our guide to last year. But what's really driving it? I mean, it's consistently up every quarter, and we're seeing margins going up every quarter. So what is driving that? What sits behind this, and how does that relate to the business going forward? So there are a number of things driving it. One, and Dave talked about it, we've talked about it, is look, our end markets are diversifying. It's 2 years ago, it was 100% mobile, and it is not that today. Mobile is becoming an important but smaller percentage of the overall business. Dave touched on it. GaN is here. It is a displacement technology, as is silicon carbide, and we're seeing that, and we're seeing it today. And I think for those of you who listened to our call at the end of Q3, I think our commentary on the market, and the mobile market in particular, may have surprised some people. And I think part of that is, look, we're a leader, and what others see doesn't mean that's what we see, right? So I think we want to be that first call when people pick up the phone and say, Gene, what are you seeing in the market today? Because again, I think from a leadership position, we're seeing things, like I said, that our competitors might not be seeing. We've talked about other markets. Our first onboard charger, that started ramping this quarter, so that's helping drive growth. And when we step back and we think about, well, what's another fundamental difference between us and our competitors. And I've mentioned this to some people, and I came here and I saw the investment in the system design centers. And I've been in the business for a while, and it's a home run. It really is. It's a much, much different way of working with customers. It's not something I've seen in my career, and there was a lot of investment there. And I think a lot of that is, look, GaN was a new technology. How do you drive it to market? And what we're seeing today is the results of those efforts. And it's not a chip design center. It's truly a system design center. I think that's very important. And so when we go to market and we engage with customers, it's an acceleration of that engagement. It really is. And so those are paying off, and they'll continue to pay off. And I think absent that, we will grow much faster than we otherwise would have. So diversification. So this is important, right? 2 years ago, we were 100% mobile. It's a great market for us. It's a big market. But I think you think about it, and it's characterized by ups and downs, a little more volatile. I think it's better for us, better for you, to see a little more predictability, a little more diversification. So you can see where we ended up, estimated to end up this year in terms of market mix in our revenue. It's less than half mobile. So even though mobile has had some strength and does have strength right now, it's still less than half the revenue. And going forward, when you look at the pipeline, it's less than 20% of our opportunities today. So Dave touched on appliance and industrial. I mean, that turned out to be our fastest growing part of the pipeline. And as a CFO, those are the best markets out there. They're a little longer to design in. They're a little longer to adopt a new technology. But once you're in, you're in. And those programs can run 5 or 10 years. And so you'll see us, as we go forward over the next few years, you'll see this transition in our business. And again, we're displacing silicon technology. And once we do that, and based on the technology we have, these are the things that will drive margins higher. So gross margins. We guided 42.5 at the midpoint this quarter. And our view is, as we develop a long-term model, we look out. I mean, it's important. I think there are premium valuations, right, for margins above 50%. And we're very focused on it. When you think about our margin expansion and how that rolls out, there are really 3 buckets to think about for us. One is strategic manufacturing investments. So we made an investment, and we discussed it earlier this year, tied around our financing. So we're making an investment in EPI, which will go right down here under us. That's a $20 million investment. So that's the first of what you would think about in terms of strategic manufacturing. I mean, that enables capacity, certainty of supply, lower costs, faster learning cycles. So that's the first step. There will likely be other opportunities on the manufacturing side to further drive costs. End markets we talked about. The more end markets become diversified, and in those end markets, they generally have higher margins, right? And that'll help drive margin. And then lastly, and I think very important is is continuing to push our technology advantage. I think you've heard from Dan, you've heard from Sid. I think it's pretty clear. I mean, we're not just saying it. The data says it. We're able to present data that says, look, what we're doing is better than what others are doing. As we continue to push that edge and push that envelope, our customers, will look at that and they'll pay us for that. And there is value in that. And that's a key factor in keeping us ahead of our competition. So the net is, look, we're 42.5 right now, and the focus, and when we look at these areas, is to drive them north of 50%. Operating leverage, I touched on this a little earlier. We're seeing it today. I think we've been consistent over the last 4 or 6 quarters about communicating to the market, communicating to you, look, you will start to see leverage in the business. And that's exactly what's happening today. I think our Q4 guide OpEx is up less than 20% year over year, but revenues are 100% up. So you're seeing that, and it's happening, and it's going through the P&L today. I think going forward, the way to think about it is, look, investment in R&D, investment in SG&A will continue to grow, obviously, in absolute dollars, but as a percent of overall revenue, it'll come down. I mean, revenues will grow much, much more quickly than OpEx. But again, the focus is we will continue to invest, in particular, those areas that will drive growth. We are very focused on growth, and we're very focused on the P&L too. So I think the leverage in the business, the investments we've made to date, are starting to flow through the P&L. So a long-term model, revenue. So what do we look at in terms of revenue? How do we look at the market, and where do we think we sit within that? So, we think we can grow, and we look at a model 6 to 10 times the market growth rate. And the way we characterize market is the power semiconductor market. And again, that's the market we're addressing, right? And that's the market, it's a $22 billion market in 3 or 4 years. It's transitioning to silicon carbide and GaN. Even if that market's relatively slow growing, we're going to grow significantly faster than that. That's what you're seeing today, right? You see it in the mobile market. Our growth tied to that market was significantly higher than the overall market growth rate in the mobile market. Okay? And so that's what we're seeing going forward. So 6 to 10x the market growth rates. And again, what's driving that? It's pipeline. It's growing, more diversified, so that'll drive growth. And again, it's extending our leadership, right, in GaN. I think that's in question, that we're the leader in GaN. And then silicon carbide. We've been in the silicon carbide business for 1 year, right? And we will take share. I mean, we will, from here going forward, we will take share. We have superior products and technology, as Sid walked through. And that's happening, and we're seeing that today. Gross margins, we talked about it a little bit. It's multiple categories. It's markets, it's products, it's technology. These are all individually and collectively factors that'll drive margin expansion, and strategic manufacturing. We will make investments. We will be prudent, obviously, with our capital, but we will look for accretive investments in manufacturing that will drive margins, drive revenue. In OpEx, we will invest for growth. We are not creating leverage or OpEx as a smaller percent of overall revenue by cutting or holding things flat. We will continue to invest, and we will invest for growth. So you will see the spend go higher, but as an overall percent of revenue, it will come down. And so longer-term operating margins, the today is north of 20%. So we want a strong operating model. We want premium gross margins, premium growth rates, which I think is where we're heading and what we're demonstrating today. We want OpEx that is, again, very targeted. We'll focus on growth. I think we're efficient in SG&A, and that'll generate superior operating margins. And then investment and capital allocation. So you collectively and others have trusted us with capital, and a lot of capital, and it's up to us to deploy it in a way that generates the biggest return for you. So where do we do that? We're committed to R&D, innovation, and growth, right? We have leads in GaN, and we have leads in silicon carbide. We do not intend, to not maintain that advantage. I mean, we're going to continue to focus that and invest in it. Again, accelerating investments, we will continue to put money into R&D. So this is in no way a story about, they're not going to invest. No, we will invest. And operating leverage, we've talked about that. So invest, revenue growth, OpEx as a percent of revenue will come down. As strategic manufacturing, look, we are capital efficient. Call us capital light. We've made the investment, or we're making the investment in in-house epi. And we will make similar investments. We won't hesitate to make those investments. That again, it's certainty of supply, it's learning cycles, it's yields, it's costs, and all that feeds into our margin profile. M&A, we've stated M&A is part of the strategy, right? I mean, we're not shying away from that. We've done 3 acquisitions over the last year or so, right? And we will focus and we'll continue to focus. We see opportunities, we look at opportunities, that are accretive to the business. So when we come to you, and if we do one and say, here's why we did it, it'll make sense, all right? We're not here to necessarily acquire technology for technology's sake. I mean, it has to be complementary. And again, it has to drive growth and be accretive. The balance sheet, we have a really good balance sheet. We have more than $170 million in cash, no debt today. So the balance sheet's in a great position, to fund the organic business and that long-term model that we were talking about. It's there, it's today. We don't need to raise money to fund that business. So we get the question, and the only reason we would go to the capital markets would be transaction related. We do not need to approach the markets right now. And shareholder returns, I think that one's pretty obvious, right? It's, we want to generate returns for you, our shareholders, that are well in excess of relevant indexes or our peers. And we've done that this year. So that's all I have. I think it's Q&A. I thought we had I'm not done yet. Hold on. I forgot to say, it's unfortunate that the Warriors aren't playing tonight. That's all I want to say. We got Lakers fan, Clippers fans, probably some Celtics fan. I don't know, but it would have been much better if the Warriors were in town. So I'll just leave it at that. Is that it? Is this like you're pulling me off stage now? Or do I get to stay up here? I get to stay. All right.
Thank you. So it's been a hot afternoon. I didn't realize how hot it was going to get in here. We've got some chairs that Harrison's going to pull across, please. Thank you very much. This is Laurie. If you don't know Laurie, in the middle, she has a roving mic. We are also taking questions from those on Livestream. And Shayo at the back is loading up the questions there with the team. So as a reminder, on stage today, we've got from the far end, Ron, CFO, who's just been speaking, Gene, CEO, Dan, COO, CTO, and this is Dave. He's the Senior Vice President of Worldwide Sales. And with that, I'll hand across to Laurie, please.
Great. When we take your questions, perhaps you could give your name first as well as your affiliation.
Quinn Bolton with Needham. I guess the first question kind of on the competitive landscape, but also sort of revenue focus from China. Innoscience is one of your GaN competitors. They have internal manufacturing on 8-inch wafers. It sounds like they may now be trying to price their GaN devices at the same cost as the silicon device, not the silicon system. So it sounds like they've got perhaps a cost advantage. How do you see them on the competitive landscape? How much of your business is done in China where they may be a pretty tough competitor? And do you see Innoscience having success in the export markets or the international markets?
Yeah, I could start. Maybe others could add to it. Innoscience, first of all, is a discrete GaN player. If you don't know them, obviously don't have GaN ICs like Navitas, and we see them definitely participating in the low end of the market. As Quinn said, they're more focused on sort of low-price discretes. Of course, with our GaN ICs, we're taking a very different approach, a system-level approach where we're integrating additional products that bring more customer value, but most importantly enables higher frequency and higher efficiency that I talked about earlier, which ultimately delivers a higher density, faster charging charger. So if you compare a discrete-based or Innoscience-based charger compared to anything we might produce, there's really no comparison at all. And there's no price point that's going to be low enough that's actually going to deliver that sort of charging experience or that performance. So fundamentally, it's a bit of a different game. But with that said, I think there's always a place for sort of lower price leaders, participants in the market to fill sort of the low end of the market, and that's where we see them participating. We don't see much success, to your other question, Quinn, outside of China. That may change over time, but certainly right now it's primarily a local low-end player in the China market.
Jack Egan, Charter Equity Research. So I think a potential concern is that Navitas, it may have great product performance, but it doesn't have the scale to compete with some incumbent power semiconductor producers. And those companies are also selling, microcontrollers and analog and all kinds of things that may make it difficult for Navitas to, win slots at, EV OEMs or industrial. And so in that sense, what can Navitas do to expand its market position in silicon carbide and or GaN, where it's competing with those much larger companies?
Yeah, I think actually that's one of the beautiful things I love about creating Navitas in this market. We all grew up in this market. We worked at larger companies, Infineon, International Rectifier, many others. And actually, it's their scale that is our opportunity. Their size leads to bureaucracy. It leads to slower decision making. It leads to risk aversion. It leads to having a hard time in terms of focus and nimbleness. And that is the exact opposite of those. That is the opportunity for Navitas. An intense focus on nimbleness, speed, and the innovation that comes with intimacy. Actually, we target a number of large markets, but in each market, you'll notice we have an acute, targeted, application-oriented approach in each one of these markets where we go very deep with customers. That has led to a unique go-to-market strategy with a lot about system design houses. That deep system expertise then flows back into more innovative, more integrative, higher efficiency, higher frequency products. All of these, I think, work together to give us a greater focus, greater customer value, greater customer intimacy, and a greater speed and flexibility to kind of serve the market. So I really think those things that might appear to be strengths for the big guys actually ends up being our strength and their weakness. And I think the results speak for itself. But I'll let others add to comments. I mean, Dan, what are your thoughts about?
Well, adding to that, in terms of scale, we do have agreements with our partners, as I pointed out earlier, that allow us to significantly expand, far beyond where we are today. Factors of several expansion in what we already have agreed, and commitments from those partners and others that we're working with to bring up the capacity and scale. And as we bring up that scale, of course, the laws of semiconductors kick in, and the price of your supply chain comes down accordingly.
Yeah, I would just add as well that the focus and the strategic importance of the power devices is increasing. So it's not that our power devices are just along for the ride with the rest of whatever the bill of materials may be. They actually focus the design in a big way, starting with the power device, whether it's GaN or silicon carbide. So that also helps, with our focused approach to the market, we can go win that design. The rest of the bill of material can follow. And we're actually leveraging, as you've heard, our system design center, close customer collaboration to optimize that bill of materials as well, which again, those bigger players can't do and aren't doing as we are.
Next question comes.
Hi, it's John Tanwantang from CJS Securities. I actually wanted to dig deeper into that question with your design centers. I was wondering how many of your competitors actually do the similar, kind of deep co-location and design integration and system, expertise that you offer. If they're not doing that, will they do that in the future, given the success you have, and kind of just give me the lay of the land, and, competitively, and how they do that?
I don't think I've seen any. Some people do basic demo boards, some reference designs. I don't think I've seen it anything approaching what we're doing on deep system level designs. That's how I describe these designs are not demo boards or reference designs. They are complete production designs, 80 to 90% complete, leaving that 10 to 20% for fast time to market with the customer, customization, interface to their bigger system. It's a pretty unique focused capability.
I would add to that, even if there is someone out there that's trying to do something like this, it's really hard to find the deep talent that we have as the leaders and as the participants in those design centers. They are coming from industry, they're top of their field, and basically leaders in the state of the art.
And do you expect to have one of these kinds of design centers at each of your major customers, or at least by end market, as you expand into them, or are they going to be more centralized?
We're exploring now expansion into energy storage, possibly parts of solar, and possibly the motor control. You heard a lot how that's taken off faster than our expectations. and appliance motor control, industrial motor control. So those are under investigation now. But we'll be thoughtful about it, as Ron said, to make sure we're still driving that operating leverage, but continue to invest very selectively and targeted where we think that's going to be very accretive to the business and show a very fast ROI. Thanks.
Tracy Wright, Baird. Quick question on silicon carbide. How do you get around some of the yield issues that some of your competitors are seeing, notably moving to 200 millimeter in terms of wafer flatness and some other issues? And also, if you could talk about the pricing and how you're charging for the specs advantages that you have relative to the competition, both in gallium nitride and silicon carbide. Thank you.
You talk silicon carbide first?
Yeah, I'll take the first part. So we are on 6-inch wafers. We're not on 8-inch wafers. 8-inch wafers are very, very expensive still. I mean, the cost per square centimeter of 8-inch silicon carbide wafers is much higher than 6-inch. So 6-inch is actually the more cost-effective process at the moment. I know there are players out there that are making big investments in 8-inch, but it's going to take a while before that investment turns into lower cost per device. So that's one thing. Flatness, not too big of an issue for us really, and our yields are actually quite high. I mean, yield engineering is not a big factor on our costs. Thanks to this trench-assisted planar process that Sid and the team have developed. It is a simple process. It's easily executable within the process capability of the fab that we use, and yields are quite high.
Maybe in the second part I can start, Dave could add, as you hear throughout the day, system level focus. That includes the bill of materials, how to push the frequency up, how to reduce the cost of the magnetics, the mechanicals, how do we integrate more around the GaN or the silicon carbide device. Those are common themes, but we're also very pragmatic and very obsessed about our customers' goals, and that includes costs, but it starts at the system cost level, obviously more so than a component level. So more times than not, when we're creating this new value and creating cost reduction, we're sort of sharing part of that, a lot of that with a customer to drive that cost reduction down, get the full GaN potential, the full silicon carbide potential, but also share it back to ourselves for that incremental margin. So at a high level, that's always guiding how we think about component level prices, is system value, system cost, and how do we share that with the industry, with the customer, at the same time drive our own profitability up over time.
Yeah, and I would just add on the silicon carbide side, the first thing we do is we ask our customers, please test our devices, because you're going to see the advantage, and you're going to leverage that advantage to your advantage, and that's going to give us the opportunity to get some benefit ourselves in terms of our pricing. So it's a self-fulfilling prophecy. You heard about the advantages. We have them tested. They see it, and then we go from there. So there's also component advantages that we take advantage of as well.
Back here. Ross Seymour from Deutsche Bank. Question on the pipeline side of things. While the size and the growth of it is impressive, I think the diversification that you highlighted, David, is even more so. But those markets are very different, much less concentrated in many cases, different go-to-market channel, et cetera. So can you just talk about the challenges in addressing those broadening end markets? Do you have the feet on the ground to do it, the distribution network to do it? Just want to think about the timetable to get to those numbers where you had mobile less than 20% of your revenues.
Yeah, thanks, Ross. A great question. So this has been a diversification strategy that's been in place now for quite some time. We've been developing high-power GaN. We just announced it in September, but I think we've been developing it for quite some time. So we've been focusing on some of these applications now for several years. With the GeneSiC acquisition more than a year ago, it gave us an opportunity to take a step back, look at our go-to-market strategy, our distribution channel partners worldwide. And so we've rationalized some of those partners, but we've also invested heavily in our direct sales team. We've brought in industry experts, veterans from other companies that have a lot of experience in these different markets. So we weren't a sales team of, let's go sell GaN chargers, which is a great market and continues to be. How do we get the value across these different applications? So we've expanded our own direct team. We've done specialization with our direct team. We've hired specialists in terms of FAEs, and we have a massive applications engineering team that is complementary to the design centers that you've heard about. and we're adding more and more of these focused resources around the world. So we're putting the right level of expertise in the direct sales team, and we're also changing and upgrading our channel partners that are more aligned with these markets that we're now focusing on.
And I would add just a little color because it's really important. It's a tricky balance. Diversification, we love to balance out the business. When one is down, two are up. We all get that as investors. At the same time, that can also dilute your focus and lead to mediocrity if it is too diverse and spread out. But the applications we pick in each market actually have a lot of synergy. So if you look at EV, where are we heavily focused, as we just heard from Hao and Dave, is the OBC. These are operating on 1 to 2 kilowatt AC to DC converters. Guess where we're focused in solar inverters is also in the 1 to 10 kilowatt AC to DC converter level. The guts of those technologies are a lot of the same magnetics. It's the same GaNSafe. It's the same Gen 3 fast. It's a lot of the same topological developments. Even go to data centers. Again, 1 to 10 kilowatts. We're focused on that high end, that leading edge where the AI processors are demanding 2, 3, 4, 5 kilowatts per rack. The underlying architecture, GaNSafe, Gen 3 fast, fundamental magnetics. There's a lot of technical synergies between the applications that we're targeting within very big markets. So we're very careful and very thoughtful as we add a new market, or more importantly, a new application, to make sure we can have that laser focus, we can bring innovative value, and we can really bring that, and that Dave's team is ready to scale into those key customers from a sales and FA and distribution perspective.
One other point on that, if you consider the half-bridge family, which we're bringing to you and sharing as a major improvement in our portfolio, we started designing that as a converter product, but we discovered very quickly and repurposed it and found that with slight modifications, we could build out a whole portfolio of converter-based products, the C-series parts, and a whole portfolio of motor-based half-bridge products. And then from that platform, we can expand and continue to improve and bring value-added features into both of those markets. So the synergies that Gene's talking about, that's another good example of how we moved from converter space into motor space.
So next question on the web here from Bill Morrison of B. Riley. What market share do you see for you in the power semi market in 2024?
Well, it depends on how you define it. I mean, clearly we look at ourselves as a gallium nitride, silicon carbide player. We're not doing silicon power devices, as we talked about. The GaN market is relatively new. It's the new kid on the block. That market is pretty small, probably sub $200 million. We believe we're the clear not only technological leader, but market share leader, high majority share, I would say, in high voltage GaN with leadership GaN ICs. That is in stark contrast to silicon carbide. We're the new kid on the block in a more mature $2 to $3 billion silicon carbide market. So we're the small fish in this big and growing pond, but you heard about all of our advantages, our unique go-to-market, the big growing pipeline. That's a tremendous opportunity to go from what's probably a 2 or 3% market share player to 5 to 10%. So I won't predict exact market shares next year, but I think you can get a feel from my comments as to where we are today, and we certainly plan on growing that. And that also drives our comments about long-term growth rates. The power semiconductor market overall is not growing fast, but it will ebb and flow. Gallium nitride and silicon carbide is where the action is. As a leader in both fields, that's why we believe we can grow 6 to 10 times faster than that overall power semiconductor market.
James, we have a lot of questions. If we could really click through the answers.
Okay. Steve just said I was too long-winded in my answer.
But much more delicately.
Right.
Hi, Torrance from Stifel. Thanks for putting this together, and congratulations on the cool new headquarters.
Yeah,
I had a question for Ron. Ron, you talked about the gross margin marching from 42 to 50 over time, and you mentioned the 3 levers. Could you just talk a little bit about how much contribution is coming from each one of those, and specifically on the manufacturing part, beyond doing epi internally, what are some of the other things that you could potentially work on for that particular lever? Thanks.
Yeah, sure. Good question. So I think in terms of kind of what contribution comes from which area, to be honest, if you looked at the chart, it's directionally, roughly equal in each area, right? So there's no single lever that would drive it up, 3 or 4 or 500 basis points or something like that. I think how we see it and how we view it is, we're seeing kind of margin improvement and contributions to that from a number of different areas. One may have a bigger impact one quarter or 2 or 3 quarters than another, but I think over time you're going to see kind of equal contributions from all of those. I think in terms of where we would make additional investments, I mean, we've talked about EPI. I think there are always opportunities to go further into the supply chain. Some at the fab level, some will say, do you want to put in some equipment, for example? Maybe there's a bottleneck somewhere in the fab, and they'll dedicate some equipment. There's that opportunity. Are there opportunities kind of at the back end in packaging where you could drive costs and efficiencies? So it's not any one single place. I mean, there are multiple opportunities, and I think they're all on the table, right, to look at.
Hi, Joe Moore from Morgan Stanley. I also wanted to ask about the gross margin. 50% as an endpoint, that's higher gross margin than we see on average in power devices, but obviously you guys have talked about the leadership you have in technology. Just, is there opportunity to move that higher over time, or is there maturity? Do you expect these markets to get more competitive? Just how should I think about, traditional IGBT margins and things like that as you guys move into new areas?
Yeah, so again, I think, Joe, and appreciate the question. We think we have a path, as we define, to get to that 50% plus level, right? The key is, this is, we're displacing silicon, and I think we would all agree that the silicon market, to a large extent, is commoditized, right? And so one of the phrases we use is, in addition to displacement, is decommoditization. So we think as Gene and Dan and others have talked about from our technology standpoint, there's a value add cell and a system cell there that we think is defensible over time and allows us to keep higher margins than you would normally expect. So sorry, go ahead.
Yeah, no, I'll just throw in, I think also, like you said, discretes, we grew up in that world of silicon discretes. We know it well, international rectifier, et cetera. And so I think it's true, as a market matures, it's going to have more commoditization over time. Silicon discretes have averaged sort of 30 to 50 points, depending upon where you're in that cycle. On the contrast, more integrated and differentiated analog ACs have commanded 50 to 70 points margin. I would say as a company, we really aspire in bringing these two together, but also not coming anywhere close to the silicon maturity and commoditization that you're seeing today. That took 30 years in the making, right, before you got to that point. We're in the very early ends of a disruptive technology before we have that risk of commoditization. But I'd say long term, we still see our business as sort of a blend of those two, which is why I think we're trying to be pragmatic and realistic and say we're somewhere in the 50s. We believe that's very practical and achievable in the next few years.
Hi, Natalia Winkler from Jefferies. I wanted to ask about some of the products that you guys have showed in the presentation that seem to have mixed topologies, right, with silicon carbide and GaN, or I guess silicon carbide and silicon. I imagine this is what theoretically would be higher gross margin products. And I'm just curious if you're seeing, is the customer adoption longer on those types of products? Is there any additional robustness tests that have to be done? I guess, is it harder to sell those compared to, typical discretes that everybody's familiar with?
My quick comment would be, I think it's faster in a way because most of the times when they showed this, we called it hybrid design. We're putting silicon carbide in the PFC, which is facing the grid power. That's where you get the most electrical overstress, and you're really looking for the most mature, field-proven device. Well, silicon carbide's been shipping in high volume for 20 years, so it's sort of a safe bet for that front-end PFC. But everybody knows that GaN IC is ultimately the fastest possible switch you can get out there, even compared to silicon carbide. You put it in that next section, that's the one that wants to go screaming fast. Howe talked about it both in data center and OBC, the DC to DC. Customers get that. Once you show that and you've optimized both for ruggedness on the front end and speed on the second, they're like, that's obvious, let's go. So I think it's going faster with that compelling platform rather than slower.
Yeah.
We've got time for 2 more questions.
Great. Steve Boffman from Divisar. I just want to follow up on Tori's question really quickly. So apparently you guys did a press briefing yesterday. EE Times reported or published an article just before this launch saying that you were potentially going to consider buying silicon fabs and repositioning them for silicon carbide and gallium nitride. And I wonder if you can just talk about that as a possibility and what that would mean.
Yeah, we certainly haven't made any predictions yesterday or today, but we make the observation, as we have in the past, what's really cool about GaN and silicon carbide, super advanced material, advanced technology. We have the best design and version of it, as we said today. really low-tech manufacturing requirements. You can build this on old 6-inch factories, 0.35 micron factories. That's a beautiful thing. These fabs are built 20, 30 years ago, fully depreciated, low cost, often excess capacity as silicon has moved on to 8-inch, 12-inch, and more advanced nodes. TSMC's building our GaN in their oldest factory in production today, Fab 2. X-Fab working in Lubbock, Texas with a fab that was built back in the 80s as well. So now we have more options than we know what to do with silicon fab guys that would love to upgrade their fabs to GaN or SiC and breathe new life into them for the next 10 or 20 years. So that's a great opportunity, and we have something to announce on it. Of course, we'll bring it forward. Yeah.
Thanks for letting me ask one more. Ross Seymour from Deutsche Bank again. Maybe just a fitting way to wrap this all up. You talked about a great growth opportunity, big pipeline, et cetera. You talked about margins expanding. How do you balance the desire for that growth versus hitting break even, generating cash, all of those sorts of things? And kind of when do you think that would happen?
Yeah, good question. So you know, again, I think the focus and where we've invested is to drive growth. What we've been consistent about, Ross, is, you know, when we get asked questions about break even, you know, we've talked about revenue on a quarterly basis in the 50 to 55 million a year range. So again, when we think about the business and investing, I think we can keep, you know, OpEx growing, but again, at a rate that's significantly lower than the top line. So I think that gives us enough resources to allocate and focus in these markets that keep us ahead. And really, we focus on that. How do we leverage what we've done and where we've invested? And there's been plenty invested prior, and how do we leverage off those platforms and just drive it forward?
Okay, thank you very much, gentlemen.
Yeah, that's a wrap.
Does that mean get off the stage?
That means get off the stage.
Get out of here.
This is a chance. Thank you. This is a chance. We've got a range of customers who are going to come up, but let's take a break. Let's get some sodas. We've got coffee in the kitchen area. Time to stretch your legs. Let's say back in 10 minutes, please. Thank you. All right, ladies and gentlemen, any stragglers? Here we go. Thank you. This is the reveal. Is it a boy or a girl? No, it's customers. It's always good. So I'm going to hand across to Dave. We've got 5 excellent customers coming up. The first one is, I can see him, he's right here. So, Mr. Dave Carroll, Senior VP of Sales.
I guess this is this live? Okay. All right, so it's really exciting for me to be able to introduce some customers. You stop listening to us, you can hear it straight from their mouths on what they see in terms of working with Navitas, how we partner together, and what it means for our futures together. So I'm really excited to introduce our first customer guest today, Rick Liu. He is the ACO Power COO. Rick has a long history of innovation in the EV industry, including production launch of the world's first automotive-grade silicon carbide module at Tesla. So that's pretty impressive credentials. ACO Power is a top-tier traction module player in China with tier 1 customers in mass production, including Geely and their associated brands, including Volvo, Zeekr, Polestar, Smart, Lynk & Co., Scania, and others. We're working together with Rick and his team to define and develop next-generation traction inverter solutions, leveraging Navitas silicon carbide performance leadership and ACO Power advanced module design, assembly, and testing capabilities to support the ever-increasing demands of efficiency and performance in the automotive space. Please join me in welcoming Rick to Planet Navitas.
Okay, thank you, Dave. And it's open? It's working? Okay. Good afternoon, everyone. And first, let me introduce myself. My name is Rick Liu. My Chinese name is Liu Jun. And in China, actually, for this Chinese name, there's over 290,000 people named the same thing. So it's better you call me Rick. And if you talk about Rick in semiconductors, in carbide, there's only one Rick here. So first introduction, I previously working in ST Microelectronics for more than 15 years, starting from early 2000. And I work in the automotive industry since 2006, Bosch, Valeo, Denso County, all my customers. So always working automotive and consumable product. And for silicon carbide, as Dave just mentioned, actually I started to know silicon carbide since 2006 or 2007. At that time, still 2-inch wafer, I remember clearly. It was for satellite and for space, for military, this high-end application, minority, not majority. The story changed starting from 2016, which I started to work with Tesla, with the California team. And at that time, frank speaking, everybody beside me, including my customers, we are not so believing so much on silicon carbide is going to work on traction application. And it's really tough because at that time, there's no such people doing such a kind of thing. The maturity of the process, the material, the device, the application, nothing is matured. It's very, very difficult. But within 6 months, we'll have the first device coming out, installed in the car, running on the street. Now there's millions of Model 3, Model Y running running on the street. I'm very proud of it. And then comes the story of ACOPower. ACOPower, I'm currently the CEO and co-founder of this company. We registered the company end of 2018. Actually, 2 weeks ago, we just celebrated the 5 years birthday of our company. And until now, ACOPower, for last year, we are the #2 in terms of shipment power electronic silicon carbide module maker in China, and the #1 in China this year. And in terms of revenue, we are talking about something like $100 million this year, and going to be double or triple next year. So this is the general information referring to ACOPower. The next stage, I'm going to speak a little bit referring to the market in China. Frankly speaking, the market in China, especially for EV market, is much more crazy than any other corner of the world. And actually, if you actually been to China, you walk on the street, it's very easy for you to identify each individual car, whether it's an EV or it's not an EV, it's traditional car, because you just identify based on the plate. The plate, if it's green color, it's an EV car, no matter it's a plug EV or it's a pure EV. And in the major city of China, I'm talking about the Beijing, Shanghai, Guangzhou, Shenzhen, all these big cities in China, at least more than 50% of the car you see on the street is EV now. And actually, according to some new numbers, I just read a number about 1 hour ago. I saw the new published number for November this year, and there's already more than 1 million EV cars sold in China for last month. That's a very big number. That's a very big number. And accumulated for this year, we do believe the number should be between 7 million to 8 million EV car. And inside of this number, roughly around 30 to 35% is pure EV, means without plug, which is the field for silicon carbide. So actually, I'm talking with and working with majority of the car maker in China. Currently, we have more than 20 design-in ongoing with different car makers in China. And all of them are really crazy to go silicon carbide, which is quite different versus 3 years ago. 3 years ago, actually, majority of them are still watching, doubting, and considering whether this is a mature technology to go forward, because people believe IGBT should be the mainstream to go. But now, the things totally changed. People talk about the IGBT and the silicon carbide at the same time. And now, I would like to say 80% of the new project for the next year and the 25 is based on silicon carbide, no matter on low voltage and high voltage. So this is the current situation. It's much, much more crazy than any other world. And also, on the other hand, we are working with some of the car makers in Europe, including Tier 1, and they are getting started, I would like to say. And according to our visibility and the market intelligence from all these customers, people are talking about mass production starting from 2025 to 2026 for silicon carbide mass production. This is including not only passenger car, but also commercial car, truck, bus, and also some very advanced technology, for example, the motorbike or the drone with people in passenger inside. So here we see a very, very good market for silicon carbide. And of course, on the other hand, in terms of supply, I also have to update you a little bit. I think the majority of you are already aware of that. Currently, all the major players in worldwide, especially for power electronics, now is investing huge money, announced a very big plan, and under execution of the expansion. And here we are talking about millions of 6-inch wafers every year production. And if you convert the wafer into cars, actually the number is really, really, really huge. But I do think the market, the demand, and the supply is kind of balanced in the next 2 to 3 years. Now still the selling market, frankly speaking, this year and next year, this is still the selling market, means there's less supply than demand. Majority of the supplier is still in allocation mode, I would like to say. But I do think the story will change starting from end of next year to 25. It will reach a certain kind of balance. Because if you talk about the car selling, we are talking about something like 60 million to 80 million car selling every year worldwide. And in China, this number is something between 20 million to 30 million in the next 2 to 3 years. And inside of this, we are talking about over 10 million EV cars. And with the percentage of the silicon carbide increased, so you can imagine actually the market is still there. And this is something really worthwhile for us to go straight forward and to devote whatever we have to do it. Okay? So this is the market, and this is the current situation, and also a little bit of outlook for the future. And talk about the cooperation with Navitas. Frankly speaking, we start to know the name Navitas, not based on this name. It was 2 years ago, we know the name as GaNSafe. And at that time, it's really rare to find any matured silicon carbide dies supplier on the market, and we are researching all of them. And I would like to say, GaNSafe, they are providing one of the top class device according to our requirements, and it's really, really attractive, which was 2 years ago, roughly, approximately. And things are changing and moving very, very fast after the acquisition between Navitas and GaNSafe, and really appreciate the cooperation between our two parties, especially the technical team. We really enjoy two things. The first thing is the technology Navitas brought to us. Currently, the Navitas device we have in our hand is one of the best devices we have, and we can provide to the market. Point number one. Point number two, we really appreciate the cooperation between Navitas and especially the support, which is mentioned also by Dave a few minutes ago. And because application is very, very, very important for this field, because this is a little bit different versus traditional consumable products, mobile phone market, or the industry market. Normally, for a car maker, for matured power electronics, for automotive application, it will take 18 to 24 months for the final qualification. So, guys, please be a little bit patient for certain news released along the way, but we really need a lot of time to be qualified by the customers. And along the way, majority of the customers, frankly speaking, they do not know very well how to use silicon carbide, how to drive silicon carbide. It's really different versus traditional IGBT device. And currently, besides some of the very, very top class customer, they know very well how to use it. Majority customer still in the middle or even lower level. We have to teach them, help them, and support them to use our device. And based on this, we really appreciate the cooperation between our team and Navitas China team, especially the team led by Charles, Sun Hao and also Justin, really help us quite a lot. And we really help the customer to overcome considerable technical issues as a blocking point in front of us. And currently, there's more than 3 projects currently ongoing between Aqua Power and the Navitas. And we strongly believe all this design-in will become design-win in the next 12 months. And we are targeting to go mass production end of next year, and the volume production. And actually, I'm not talking about a small volume, but a very huge volume starting from year 2025. And currently, I'm already planning my business forecast and the revenue forecast based on a considerable portion based on Navitas dice. And hopefully, these guys could do a great job, and we can go success together. And the very last point is currently, just now I have the discussion with Dan together outside during the coffee time. And we are really think how to move forward in terms of business model. Besides the buy and sell business model, but also we are thinking how to explore the potential business opportunity in front of all of us. This means not only in China, in Europe, in USA, we can work together to overcome all the customers we may serve together. That's our focus for the cooperation between Aqua Power and Navitas. Thank you.
Okay, thanks very much, Rick. And we're going to really appreciate that. We're going to change gears a little bit. So we're going to come closer to home here. So it's really my pleasure to introduce a neighbor and an old friend, Steve Maloney. Steve is the CEO of Belkin. He's responsible for the Belkin brand. And why I say they're our neighbor, Belkin is a California-based accessories leader delivering award-winning power, protection, productivity, connectivity, and audio products over the last 40 years. Designed and engineered in Southern California, sold in more than 100 countries around the world, Belkin has maintained its steadfast focus on research and development, community, education, sustainability, and most importantly, the people it serves. From the humble beginnings of a garage in 1980s Southern California to a diverse global company today, technology company today, we remain forever inspired by the planet we live on and the connection between people and technology. So we have a lot in common. Local SoCal folks, we've actually worked for many years together with Belkin since the early days of GaNFast ICs to bring the best user experience to mobile charging. Please join me in welcoming Steve to Planet Navitas.
Yeah, thank you all very much. Hopefully I have a couple of slides that are going to be coming on the screen here in just a moment. See if I can navigate through that. So thank you all for inviting me here to participate in this today. Thank you, Gene, also for the invitation. It's nice to see you, and congratulations on such a great event. It's nice to see the turnout here. Thank you, Steve, also for the introduction. We appreciate that very much. I'm going to share just a little bit about Belkin and who we are and how we view the world, and then I'll talk a little bit about our relationship with Navitas. We do care deeply about a few things, and these are pillars that we've established across our organization that we talk about with all of our partners around the world. We have an office in El Segundo. It took me about 15 minutes to get here today, so that was really, really nice. We've invested in labs and industrial design, and for us it starts with consumer insights. So we really want to understand how do consumers want to interact with technology? What do they need to get the most out of their technology? And how do we design products to make that happen? We've invested in these facilities for the last 40 years. We moved into our new facilities in El Segundo just over a few years ago, and when I look around this space, I see a lot of the sort of inviting things that you want to see in an office just like ours. So because we have those spaces and we're able to react very quickly, we can fast prototype using that consumer insights input that we've received to design products. And part of that leads to our relationship with Navitas and building products into those solutions. We also care deeply about the environment. Sustainability is a hot topic. Climate change is obviously a hot topic. We care deeply about those things. We ship in excess of 150 million units per year to our consumers around the world. And we know we need to be really cognizant of the impact we're making around that and make choices in the kind of products we're designing and bringing to market to help reduce the impact that we're making. And I'll share a little bit more about that in just a moment. We also care about the community that we're in. We talked about Southern California. We've been here for 40 years. I've worked at Belkin for just about 20 years now, so I've been there for quite a while. And we invest a lot in the community around us. We have an on-site school that we host that hosts about 60 students that are having an opportunity to earn college credits while they're going to high school and earning their high school education. So it's quite different for us. We think it matters, and we think it matters for the communities that we serve, that we do those sorts of things. So just a little bit of history on us. I'm going to go a little bit deeper into our efforts around sustainability. As I mentioned, we're shipping a lot of products into the world every year, and we need to take steps to try and reduce the impact that plastics are having in our environment, and the waste that's generated by the products that we're serving. Of course, we want to make sure that we're developing and building and bringing to market high-quality products so that you don't need to just rebuy them all the time, right? We want them to be high quality and make a difference in the world. We have also made a big shift in our products as well, where we're building post-consumer recycled materials into all of our products now, or excuse me, in the first 200 or so products that we're shipping now, which is dramatically reducing waste. It's dramatically reducing the amount of virgin plastics that we need in our products. We think that that's the path that we're going to stay on as an organization. So we're tackling Scope 1 and 2 emissions. Scope 3 emissions are right around the corner. This is a very difficult thing to solve for, but we're committed to doing it. We're doing it because it's the right thing for us, for the consumers. We think it matters, and the right thing for the environment as well. So we have aspirational targets to reduce those Scope 3 emissions quite a bit. And as you're learning more about this and hearing more about that, just know that Belkin is focused on doing the things that we need to do to make a positive contribution to the climate and the environment around us. We invest a lot in relationships. Navitas is one of those relationships. We work with some of the biggest device manufacturers in the world, and we've had a long history of building what we believe to be our really complementary accessories to the hero devices that we interact with every day. So it's a big focus for us. We want to work with the best and the brightest companies in the world. It helps us stay in front of the technology curve. As you know, you've got a new, potentially iPhone in your hand. That iPhone now operates on USB-C. So how do we make sure that we are designing products that are going to meet those needs early enough and is going to charge optimally? We need to invest in those relationships to have that kind of visibility. And so we combine that with the consumer insights that we're bringing to the market, and that's how we stay relevant and how we've stayed relevant for the last 40 years. And we think that the combination of all those things are going to lead us to the next 40 years of our growth. So what are we doing with Navitas? If you reflect on this product on the left, this is a straightforward GaN product. It has a single output port and is 140 watts. The product on the right that leverages GaN technology has 4 ports. So you're saving a lot of space, you're saving a lot of material. It's made from that post-consumer recycled plastic that I mentioned, so it's better for the environment. We also use plastic-free packaging, and of course, you could take one charger to serve everything, so you don't have to have a bag full of chargers and accessories to meet all your needs. So we're able to do that because of the GaNSense technology that we've integrated into these products, and our teams are working very closely with John Steven, I saw him over there, to help develop these products and bring them to market. The next one I'm going to talk about is this laptop wall charger. So on the left-hand side is the first product that we designed with, one of the first products we designed with Navitas that leverage GaNFast. If you look at the one on the right, you can see the footprint is substantially smaller. So because of the efficiency that you can get from using GaN technology, your thermal issues are much smaller. So you can design much smaller products, reducing the amount of plastic that's required, make it much lighter, and of course, that all contributes to the environmental issues that I'm talking about while you're still getting the performance that you need with a product like this. So we're talking about this to the press. We're talking about this to the people who will listen. We're leveraging this with the influencers that we work with. These are some of the examples that we have around people that are taking notice, talking about GaN and talking about our relationship and what we're doing in this space. People are paying attention. So watch this space. I think you're going to see it continue to grow. Here's the visual of the product. So these are the sorts of videos that we're showing to consumers and to our customers. This one happened to run in a very public location together with Navitas. We designed that and are telling the story around GaN and what it can do. We like that product lineup a lot. It's resonating a lot with our customers and consumers alike, and we're really proud to be working with Navitas. So thank you very much.
Okay, we're going to switch gears now. We're going to go back into the world of electric vehicles. This is going to be a video message from one of our key customers in China. This is Flit Guo from VREMT. VREMT is that system integration power semiconductor system company that is part of the Geely group that we talked about earlier, that we've been working very closely together with to develop leading edge 22 kilowatt integrated OBC DC converter solutions. We brought that product to market in less than a year, which is really astounding. So you'll see a video from Flit Guo. Flit Guo is the general manager of VREMT Automotive Electronics Division. VREMT is a subsidiary of Geely and their lead internal power systems development partner for Geely and their associated EV brands, including Volvo, Zeekr, Polestar, Smart, and Lotus. VREMT and Navitas have created a joint development lab enabling definition, design, and release of the products that we've been talking about in record time to market. So please enjoy this video message from Mr. Guo.
A warm hello to everyone. This is Philip Guo, Vice GM of Related E-Mobility Technology, Ningbo Ltd. VREMT for short. As a subsidiary of Geely Group, VREMT was established in 2013 based on the batteries, electrical drive, and the vehicle charging of new energy vehicles. VREMT seeks technological breakthroughs and innovation against the backdrop of its 10 years of development. It gradually expands its business to fields such as charging and energy storage. A comprehensive energy business development system and an all-around new energy eco-chain have taken shape, thereby providing safe, efficient, and intelligent energy solutions for global users. As everyone is aware, millions of homes have gradually begun choosing electrical vehicles, which is one of the optimal forms of automobile in the future. Long range and quick charging speeds would accelerate the development of EV industry. Wide bandgap semiconductors, silicon carbide, and gallium nitride offers high efficiency and extremely high switching frequency. A smaller system size and lower cost than traditional silicon chips. These significant benefits make it possible for the EV power conversion system to provide EVs with quick charging, stronger accelerations, longer range, and low cost. As the global industry leader in the world of next-generation power semiconductors, we believe that Navitas, with its advanced and mature GaN and silicon carbide technologies, is of great value for VREMT R&D teams, and its expertise of high-frequency power system will significantly shorten the time it takes for VREMT system to us of prototyping and market. And that's why on November 1st, 2022, VREMT and Navitas announced the opening of an advanced joint R&D power semiconductors laboratory. The lab will bring together professional VREMT system design team and highly qualified Navitas engineers. Both parties will work together and take advantages of the performance strengths of GaN and silicon carbide, including high-frequency magnetic design, plus advanced packaging and modules to create higher power density, higher frequency efficiency, and lower system cost power electronics system for EVs. Okay, thank you. That's all. I wish Navitas Investor Day and the opening ceremony of new headquarters a huge success.
Great. So, Sheshe, Mr. Guo, thank you very much to our partner at VRAM to take the time to make that video. So we're going to move back to the mobile and consumer space now with another close partner of ours. I'm really pleased to welcome Adam Wiseman. And Adam is a member of the PR team at Anker Innovations. Anker is a 12-year-old company that has become the #1 mobile charging brand with a number of other brands under the Anker Innovations umbrella, from audio and video to robotic vacuums, home security products to 3D printers, and soon to come whole home solar backup products. Navitas and Anker have worked together as early GaN charger pioneers to jointly define and launch leading edge mobile charger products, and we continue to collaborate on new products together. Please join me in welcoming Adam to Planet Navitas.
All right. Oops. Thanks. Okay, good afternoon, and thanks, David, for that great introduction. Again, my name is Adam Wiseman, and as David said, I'm part of the PR team at Anker, and thrilled to be here to give you a quick overview of some of the products, as well as our exciting partnership with Navitas. As a leader in consumer electronics and the world's #1 mobile charging brand, it is our responsibility to find smart ways to reduce the impacts our products have on the environment. Earlier this year at our Anker Recharge event, Anker Innovations officially pledged our commitment to making our products packaging plastic-free across all our brands by the year 2027. However, we have a bigger e-waste problem to solve. The mobile charging industry ships more than 4 billion new chargers each year. This represents an estimated 300,000 tons of e-waste annually. It also means tons and tons of cables and plugs that consumers and our landfills just don't need. This is largely driven by the lack of universal charging standards and chargers designed to charge just one device at a time. I didn't write the presentation, so. Back in 2018, our CEO, Stephen Yang, made a prediction that more and more mobile phone manufacturers would actually stop shipping chargers and cables with their new phones. And we have seen some great progress here. Several of the top mobile phone brands have begun removing chargers and plugs from their new products. And this has helped to eliminate an estimated 23,000 tons of potential e-waste each year. At Anker, we predict that over the next 3 years, as much as 85% of all mobile phone brands will follow this trend, potentially eliminating another 67,000 tons of e-waste each year. Having a single mobile charging standard, such as USB-C, is helping make this an easier decision for many of these brands. But we need to do more. Today's USB-C standard is much different than it was even 6 years ago in 2018. The newer USB-C 2.1 standard supports a power output of 240 watts. Whoops, went the wrong way. This means that USB-C can be used for much more than charging our phones, e-readers, and tablets. USB-C is ready to charge and deliver power to just about any consumer electronic product. And this is what Anker has been working on, a whole new class of USB-C chargers, not focusing on a single charger to charge one device that's thrown away year after year, but a high-watt charger that that could power multiple devices at the same time. Most of us here know that GaN is a material far superior to silicon in managing power. It offers lower resistance and higher efficiency. As a leader in GaN, it was an obvious choice to partner with Navitas to find ways to integrate this exciting technology into our charging solutions. In 2019, we launched our PowerCore Fusion PD, our first charger featuring Navitas GaN-fast power ICs, bringing a game-changing shift to mobile power. But our relationship with Navitas has grown even stronger over the years. In 2022, we entered a strategic partnership deal with Navitas, and through this agreement, dedicated engineering teams from both Navitas and Anker were co-located at our Anker offices to develop and launch new products. Having our teams work side by side helped us dramatically accelerate the time to market for our next generation GaN chargers. It was here that Anker began to fully leverage the power of GaN, combining Navitas GaN-fast power ICs with several of our own technologies and redesign the mobile charger from the ground up. Today, Anker's new GaN Prime chargers are on average 30% smaller than chargers used in silicon, which means a major reduction in the amount of plastic used to produce our chargers. GaN Prime chargers are also more energy efficient, reducing the energy loss in each charge by more than 7%. GaN Prime chargers can safely charge mobile devices even faster than legacy charging technologies. With GaN Prime, we are building devices that are faster, safer, and more sustainable. For example, this. Whoops, I'm getting behind myself actually. Okay, back on. This is the Anker 747, our GaN Prime 150-watt multi-port charger. It even has a flip-out plug. Pretty cool, eh? By leveraging Navitas GaN-fast power ICs and our own proprietary technologies, we have created a charger that is 38% smaller than Apple's 140-watt single-port charger. But it's powerful enough to charge 2 laptops at high speed or power up to 4 devices simultaneously. Thanks to partners like Navitas, Anker is creating products that are better for the environment without downgrading the user experience. Looking into the near future, you will see USB-C devices to charge almost everything, one standard to charge them all. If our industry can get behind this, then we could reduce hundreds of thousands of tons of e-waste each year. And it is innovators like Navitas who are helping create technologies that will get us there. So on behalf of everyone at Anker, thanks to Navitas for having us here today and looking forward to continuing our partnership into the future. Thanks.
Great. Thank you very much, Adam. Really appreciate that. It's really exciting and long history together with Anker. Okay, so last but certainly not least, I'm really excited. We're changing gears again. Now we're moving to the roadside charging and next generation power system space. This is a very exciting, innovative company, DG Matrix. I'm really pleased to have Haroon Inam join us today. Haroon is the CEO and co-founder of DG Matrix. DG Matrix is revolutionizing the EV charging landscape with up to 10 times smaller fast DC chargers. Their technology can also integrate distributed generation to alleviate utility feeder constraints, in essence providing a highly integrated microgrid for charging and building power. DG Matrix is about 1 year old, is installing pilots this coming quarter, and is already working more than a 1 billion sales pipeline today. Navitas and DG Matrix are working together strategically to leverage Navitas high-performance silicon carbide to enable this vision for 10 times smaller roadside chargers and advanced new energy applications. Please join me to welcome Haroon to Planet Navitas.
Good afternoon. So I'm pleased to present DG Matrix to you. We have a very unique power conversion engine that can apply to 3 multi-billion-dollar markets. 98 to 99% of that engine is common across microgrid, EV charging alone or EV charging with microgrid, and in data center applications. This is a picture that was completed by the top consulting firm in the world. When we brought them in to realize how big this market was, we asked for their help. And they gave us a vision that's clearly expressed in these slides, that with the reduced materials we use and the high level of integration we offer, we can electrify villages in Nigeria, schools in Indonesia, medical clinics in Saudi Arabia, or anywhere else on the planet. We're trying to create a cellular micro-utility, and we are releasing the first pilots in Q1 of this coming year. Do you realize that disrupts a multi-trillion-dollar industry without putting in huge infrastructure? The first product that we are releasing is a 200 kilowatt EV charger. This charger is 1/4 to 1/10 the size of anybody else. You're going to see the metrics coming up in just the next 1 or 2 slides. In addition, we can combine PV, batteries, EV, fuel cells, distributed generation, or multi-fuel generation in a unit double the size of the one that's shown. Nobody else has this technology. We can put up EV charging solutions on highways where there is no utility, and we can use the same system to also power up buildings with incredibly high surge current loads. None of this would be possible without game-changing semiconductors like silicon carbide. And we're very pleased to get help from Navitas on how to apply their lowest RDS(on), that's a measure of how much loss you get and how much surge power you can provide, transistors in our applications. Here is a comparison of our charger versus brand B. They've been around 8-10 years. Brand T, they've been around 20 years. Brand C, the 400 kilowatt unit, who has spent $1 billion of development money. And look at the metrics of where they are and look at the metrics of where we are. We are so much more dense, not our people, but our chargers. Right? And that density, you know what it translates to? It translates to the least amount of heat that's being generated in these chargers. It translates to a far smaller footprint that can go into Manhattan, that can go into downtown LA, that can go into Seattle, where large chargers are not going to fit that easily. It's creating a multi-billion-dollar TAM just by the size alone. The fact that you can now manufacture this in 1 labor hour, final assembly of our product is 1 labor hour. The final assembly of industry is 20 to 30 labor hours. So we need only 20 to 30 people to produce $100 to $200 million of chargers, 1,000 to 2,000 chargers, in a factory just slightly larger than what you're seeing here in this room where we're all sitting. That is a huge impact on sustainability and decarbonization. Why? You only need 20 to 30 people to come into the factory every day. That's it. You don't need 200 to 300 people. You don't need a factory footprint of 200,000 square feet to do it, maybe 15,000 square feet. So it's all enabled by silicon carbide at first, a new circuit that we're pioneering, complex controls that we're dumbing down, and a cooling technology that we're trying to make better. We look forward to even the next generation beyond this in cooperation with Navitas. And we think that we can leapfrog ourselves once again with their help. That is a comparison for fleet charging using our standard 200 kilowatt building block against brand C. Brand C did $250 million last year, up double, more than double from their backlog. And now you can see why we have $1 billion+ pipeline. We have so many customers interested in pioneering our products in the field. The volume difference and the footprint difference is huge. Every major fleet aggregator that we spoke with at the last big show in Las Vegas says they can't fit brand C or brand A. Brand A is a multi-billion-dollar global conglomerate, and with their thousands of engineers, we have leapfrogged them with our technology enabled by silicon carbide. Ports, suburban FedEx stations, Amazon delivery stations, they don't have the room. Any one of those customers could be a $100, $200, $500 million account for us, and we have many of those folks lining up for pilots. Here is another thing that we're changing in this industry. Our technology is putting out a LRU, line replaceable unit, at 200 kilowatts. That's a fraction of the size of people at 40 kilowatts. If you look at the amount of kilowatts per liter, this unit measures about 18 kilowatts per liter, if my math is correct. That's far beyond the charts that you just saw today. There are two converters. The other one is about 7 to 8 kilowatts per liter. So we're industry leading already. And what we think we can do in the next step with their help is going to be even smaller. So if we are going to decarbonize, we are going to electrify, why don't we use radically less material in doing it? And by the way, that's far cheaper and simpler to repair and send via FedEx than that 220 kilogram set of LRUs on the other side. Why silicon carbide and why Navitas? Well, we tested a number of devices, some of them from very large companies, some of them from other companies, and we found Navitas performance for the on-time resistance of the device to be best in class for whatever we have tested to date. That gives us an industry-leading efficiency of 95 to 97%. In addition, if we want to increase that efficiency, which is desirable for lowering operating costs, all we have to do is buy more silicon carbide from Navitas. That's it. I thought you would like to hear that. Thank you very much. Okay. Thank you. Thank you. If DG Matrix doesn't make it, I hope to launch a second career in comedy. So in addition, we have tested their devices, and the high voltage breakdown nature is astounding. How much it can take in spikes, which really points to the resiliency when you put this on dirty grids, right? You're going to put this on a dirty grid in a developing country, you're going to see a lot of sag, surges, and spikes. So that high voltage breakdown, in case you have an escape, is very, very helpful. But I think the most helpful thing that we find about Navitas is not based on physics or high voltage breakdowns. It's based on the culture and the collaboration and the openness and the warmth that these folks greet us with, and they treat us as if we're somebody special. That is what drives the relationship to be a true partnership and not a transactional relationship. We are not after the lowest cost silicon carbide. We're happy that they make 50% margin. There's more than enough money to go around. We want that relationship so we can leapfrog once again with their help. That pipeline comes from channel partners, it comes from OEMs, and it comes from end users or users that'll be deploying the chargers on their fleets. You see some of the statements, and the #1 consulting firm, I'm not allowed to name them, has pointed out that we have the most potential to revolutionize the EV charging landscape. So one day, we hope to be holding an investor day also and show you what our growth is. Today, we're just launching pilots. In addition, there are customers that are pointing this out, and some of those multi-billion-dollar conglomerates are in chats with us to source our charger, but put their brand name on it. That's all we have. Thank you very much for listening.
Thank you, Arun. Okay. Time for a wrap-up from Gene, our CEO. And after this, we'll go into tours, and then more fun starts.
Okay, very brief. First of all, love those customer presentations. I hope you did too. We heard a real wide variety from tens of watts to now we're headed to kilowatts to now megawatts, seeing the impact we can have with these partners. You heard a common theme around system support, technical support, integration, around common culture, common mission, and some pretty cool benchmark technology that's making it all happen. I just want to hit a few of the main takeaways today. Obviously, we're proud of the recovery and growth of the stock throughout the year, beating the stocks by 2 times, 4 major technology platforms, each one disruptive in the target markets we talked about. The extraordinary growth in the pipeline, 65% up, 1.25 billion. And of course, in the next coming decade, 2 decades, 3 decades, $1.3 trillion electrification opportunity. Very excited about all of these main metrics. And we're excited about getting you guys out there to take a look and tour the rest of our facility, demo rooms, and a very special experience at the Electrify studio. So with that, I thank all of you, and I'm going to turn it back to Steve to talk about next steps for the day. Thank you, Steve.
Thank you, Gene. So this is where it gets fun. If you look at your badges, you have a dot on them. And that means you're in that group. So you're a yellow team, a blue-green team, etc. And the guides for the groups are straight behind us. Emma is yellow, Mallory is green, I think Shia is red, and Grace is? Grace is blue. Okay. So we do have 8 stations. The key is to be on time because 10 minutes per station, that's 80 minutes. It's been a long day, so let's try and keep it snappy. However, we will have lots of time to talk. Obviously, the hosts are there. You can talk to the other team members going past. This is the end of the live stream. So those following along in the office or at home, depending on the time zone, thank you very much for participating. The videos from the tour will be online by the end of tomorrow Pacific time. So if you missed the tour by not being here in person, you'll see those tour videos and not miss out on the action. So thank you to those from live stream.